and further structure recognition is done through rule-based strategies. The information extraction itself is done through keyword search and location heuristics. Payment extraction is also available in bulk from bank statements with inbuilt duplicate avoidance. For demonstration and testing purposes, artificial bank statements were generated from HTML code. Visualization analysis of expense history is another feature of the application, as is future expense prediction through autoregression. And finally, the application is available in both the English and German version. This is the model used for the table and column detection. It is heavily based on the tablenet architecture with a slight modification in that instead of VGG19, it uses VGG16 as a basis for the encoder. And here we can see all layers up until pool 5 are actually VGG16 layers, with the last two, which would have been fully connected layers, have been convolutionalized through COM6 plus dropout. And then the decoder is split into two branches, one for the table and one for the column prediction. And then this reinforces the fact that tables must necessarily contain all of their columns. And so they will reinforce that through the back propagation into the common encoder. The upsampling itself is done through transpose convolution along with skip connections from earlier pooling layers. Here is an example of the output. It will be binary masks of the table and the column. For anomaly correction, a few processing steps are undertaken, as well as on the binary arrays themselves, as well as on the generated images of the masks. For example, erosion. And here we can see how an incomplete separation of columns was rectified in the right side. For the table, for the row detection, the detection of visual ruling lines is first performed, but also the line spacing and which columns are filled in at each level are taken into consideration. The information extracted are the recipient or the company name in most cases, the date, the total sum, the type, meaning receipt or invoice, and the individual purchased items. Bank statements are generated from HTML code where building blocks such as ATM, withdrawal, incoming transfer, and so forth are taken and then parameterized, and then can be stacked arbitrarily to generate new statements. The payment extraction is also done through keyword search, and the duplicate avoidance with previous tracked expenses is done by first checking if they have an identical date and sum, and then a string similarity check between the recipients is undertaken through Levenstein distance. Visualization, the application gives an area chart of the expense history, remaining amount, expense prediction for configurable interval, and so forth. The architecture of the application, it consists of a client which will be accessed through the browser. This communicates through HTTP with the runtime server, which manages the database and communicates with the API that connects all of the different document analysis components, such as expense prediction, bank statement recognition, and so forth. The AI model and bank statement generation are not intrinsically part of the workflow, but their artifacts are used. Here are the results on the openly available ECDR 2013 table competition dataset compared to the ones from the original TableNet. This model was trained for 15,000 epochs on Marmot and a closed data set of manually annotated financial documents in the German language, while the original was trained for of over 5,000 epochs on data sets more similar to the ICDR. We can see that on a sample of financial documents it hasn't previously seen, the model performs way better. And also the check for the autoregression, so real data versus the predicted in blue. This was also done through actual personal expense history. And now for a short demo. I created a user demo. We're going to sign in. So the application is also available in German. You can see this here, but we're going to be using the English language. Okay, so I also created a demo budget. A new one can be created here, but let's enter. So expenses can be added manually, but let's upload an invoice. This invoice specifically, which has the name Edeldienstleitung and so on, the date 28th of February 2017, and the sum being 912.37. So I'm gonna upload it. Here I also created an empty directory where a few intermediary processed images will be saved. This is the reason why the algorithm also takes a bit longer than usual. There we go. And it recognizes all fields correctly. So we want this date to be within the budget parameters. So let's put it to 2021 and May and the 1st of May. So we're going to save that. And then we're going to upload a bank statement. And the bank statement is an artificial one, but it also contains a purchase which has the same sum, date, and a very similar name. So this should be recognized by the application as a potential duplicate. Yeah. And it saw it. It recognized it, so we can delete it. Now the expense history looks like this, starting from 900, and here we can see the separate expenses. And the expense prediction, this is the estimate amount the user will have by the 30th of May, which is the end of budget. But we can pick 1 week ahead, in 2 weeks, how much they'll have, and in 1 month. And for the images that were actually generated, here we have all extracted words. Here we can see the tables and columns detected. And here we can see the row delimitations. Thank you for your attention.
Thank you. So I saw that you processed JPEG files and PDF files. What other kind of files can you?
It only works on JPEGs and PDF files. That's for no other reason than because of that validation, it would work just as well on PNGs and so forth. But for testing, I just used the GPJs.
Okay, and it was not clear because in the end you got only one value at the end of the table. Or what was the value that you got?
In Python or in the
reason that you scan the entire table when you have only one?
That's because why we scan the entire document?
Yeah.
Because things like the individual purchased items, the sum and the date are found inside these detected tables, but company name and the type of invoice has to be looked for outside of it.
Okay. Thank you.
Thank you.
I think that we can safely go to the next presentation.
Thank you.
Let me check if Vlad Petrean, LSTM, VS, Arima, a time series forecasting comparison. So from Technical University of Cluj-Napoca, Vlad Petrean. Again, the same observation, you have 12 minutes and 3 minutes for discussion. We don't hear you.
Your mic is closed. Now you froze.
Let's check if I just send a short message. Is leaving. Shall we?
Yeah, we can move on with the next, and afterwards we can come back to blood. Next will be, or is that your proposal?
Should we skip to the next technical university student? Okay, Aj, David, Sabo, Balint, if they are here.
Yes.
Here.
So I think that we go to your presentation about the attack surface of Windows subsystem for Linux.
Okay, let me share the presentation. So my name is Balint and my colleague is David, and in the following minutes we are going to present our work entitled Attack Surface of Windows Subsystem for Linux 1 and 2. So what is WSL? It's short for Windows Subsystem for Linux. It basically allows the user, it's a facility built into Windows that allows the user to run a Linux distribution besides Windows. So the user does not need to have a dual boot setup or a third-party virtualization solution like VMware or VirtualBox. Architecture-wise, WSL 1 and 2 differ slightly. The processes, the Linux processes, are implemented as Pico processes on WSL1, which are sort of Windows processes but with some differences. And these processes can call system calls, and these system calls will be emulated by the lxcore.sys driver. And on the other hand, WSL2 has a completely separate and complete Linux kernel that runs inside a virtual machine powered by Hyper-V. So in the context of our research, the attacker wants to inflict damage on the Windows operating system, to steal files, to encrypt files, to spy on the victim. And the fundamental questions that we asked ourselves are, can an attacker hide inside WSL and execute the malicious commands from there? And if so, can existing system monitoring tools and antiviruses detect the presence of an attacker inside the WSL? Our contributions are that we created a post-exploitation framework tailored for WSL1 to mimic the capabilities of an attacker. We ran the commands of our framework with the monitoring tools on Windows activated, and we checked what really goes on in the system versus what is the visibility of the monitoring tools running on Windows. And lastly, we proposed two methods for monitoring the actions, which can augment existing EDR solutions. I will skip related work. For an attacker, we propose two scenarios in which an attacker can make use of WSL. The first one, an attacker sends an infected mail to a victim. The mail contains a document which will run a script the script deploys the WSL virtual machine and runs some malware inside the machine. In the second scenario, we already have a WSL machine deployed, which runs an exposed web service, and the attacker exploits the web service and deploys its malware. So we ran the commands from our post-exploitation framework with the monitoring tools active. We collected and analyzed logs, and we observed the difference between what the tools see and what is really going on.
So the post-exploitation framework that we built is very similar to existing post-exploitation frameworks, but it is tailored for WSL. It has the client-server architecture, meaning that an agent is running inside the victim's WSL distribution, and an attacker can task this agent to execute commands. Here you can see an example how the two client and server can set up and how a simple echo command can be run. And in the following slides, I will present each of the commands of the post-exploitation framework, what it does, and what is the visibility on both WSL1 and WSL2. Our first command is reverse shell, which starts a shell with the STD-in and STD-out redirected to a TCP socket. And in both cases, on both WSL1 and WSL2, Wireshark is able to capture the command given and the output of the commands. And it is notable that on WSL2, a separate virtual adapter is created for this reason. Our next command is run arbitrary commands. Here we can differentiate in two cases. In case of Windows executable launched and Linux executable. In case of a Windows process, in both WSL1 and WSL2, WSL.exe launches the process which is specified by the attacker. And in case of Linux processes, the following process tree can be observed, Python being the post-exploitation framework launching -- and finally the executable which is specified by the attacker. In case of WSL2, no tool was able to detect a process launch. Our next command is persistence on Windows. Here an attacker drops a persistent script in the startup folder, which allows the attacker to have access to the machine even after a reboot. In case of WSL1, this action is correctly attributed to the post-exploitation framework, and the behavioral detection engine flag this action as malicious. The same can be said of WSL2, but in case of WSL2, the action was attributed to dllhost.exe instead of the post-exploitation framework's process. And the next command is persistence on WSL, which is very similar, but instead the bash profile file is changed inside of WSL. On WSL1, this action can be observed and attributed to the process, but in case of WSL2, no write can be observed, only a write to the .vhd backing file for the whole WSL2 file system. The next command is saved web credentials, where the attacker tries to steal saved passwords in the popular Chrome browser. In this case, the local state file will be read from the user's directory, and this action is flagged as suspicious by the behavioral detection engine on both WSL1 and WSL2, but on WSL2 it is attributed to dllhost.exe incorrectly. Our next command is audio capture. Basically, on WSL2, a new feature was introduced which allows accessing the host microphone of the system. And in this case, we observed no visibility other than the traffic between the attacker's machine and the victim's machine, as you can see here. Ransomware is our final command, which encrypts files and finally renames them with the bad luck extension. On WSL1 and WSL2, a write and a rename can be observed, but on WSL2, this action is attributed to dllhost. To summarize, the semantic gap looks as follows. Linux process creations on WSL1 are visible, but on older versions, the arguments are not visible. And this action is not visible at all on WSL2. Windows process creations are visible, but the parent process is incorrectly attributed to WSL.exe. File system operations are visible on WSL1, but with previous mode equal kernel mode. This, as explained in the related work, may be ignored by AV vendors for performance reasons, and this action is not visible at all on WSL2. File system operations on the Windows file system are in the same category on WSL1, but on WSL2 they are visible, although incorrectly attributed to dlhost.exe. So in order to reduce this semantic gap, we want to augment existing EDR solutions, and we have to take into consideration the architectural differences between WSL1 and WSL2. So we propose two separate solutions for them. For WSL1, since it emulates Linux systems calls, we can rely only on user mode components for monitoring, and the solution that we chose is ALDI preload. ALDI preload is an environment variable that points to a shared object, a kind of DLL. And this shared object can override functions. And this allows us for extra monitoring, as you will see in the following slide. Just a second. So here is an example where we override the rename function, and we introduce some basic logging where we log the old path and the new path of the file. And for the ransomware command, this is the output that we get. You can see that the homework.zip was opened, then it was written, and finally homework.zip was renamed with the bad luck extension.
In case of WSL2, we propose a different solution, eBPF, which is short for Extended Berkeley Packet Filter. WSL2 has its own Linux kernel, so it's not simple to monitor activity, but we tried a tool that is called Procmon for Linux. It's based on eBPF. We can basically add hooks on the system calls, and we will get the system call, the parameter, and their exit statuses. And using this eBPF technology, we can build our own filters with dedicated parameter parsers. And a few examples: I wanted to run the ls command whenever Windows boots up. This command lacked visibility without Procmon for Linux, but with this tool, we logged that Python opens the persistence file and writes our command inside it. And in the next example, we did persistence on WSL, basically wanting to execute ls when WSL boots. For this, we modified the bash profile file and wrote our command inside it. And all of this is visible using eBPF, which was not visible at all with the previous monitoring tools that are running on Windows. As a conclusion, we created our PostExploitation framework, we ran the commands from the framework and observed the semantic gap and the lack of visibility of monitoring tools, and we proposed two monitoring methods to reduce this semantic gap and gain more visibility. That would be all. Thank you.
Thank you for your presentation. One questions from me and maybe some others from audience. So did you test with Ubuntu, or it's working with other variants of Linux operating system?
So we tested on Ubuntu, but inside WSL you can install other distros as well, like Kali, Linux, Debian versions, and so on. We ran our tests on Ubuntu.
And you are quite sure that it will work similar with all the other distribution?
Yes, the architectural differences. I mean, this semantic gap is coming from the architecture of WSL itself. It should be distribution agnostic, so the distribution shouldn't matter.
Okay, thank you. Other questions, if there are?
I have a question. So it's independent of the distribution, but it's independent of the shell, the type of shell, if it's bash or sh, or because it's about it should be somehow related with the interpreter.
You mean the commands to be related to the
Yes,
interpreter?
I think that the questions relates to the fact that you can install different shells inside your Linux distribution. Core shell, bash. Yes, that's.
Yes, you can, and well, every attacker can install his own shell if he wants to, but our solutions proposed for monitoring will cover any shell because we go on a lower level. We try to filter the system calls themselves. We don't really look at which shell the attacker uses.
Okay, thank you.
Can we go to the next?
Yes, of course. So we will continue with Ungureanu Ionuț Vladimir, secure live communication through cryptography, an open PGP perspective.
Yes, I am here. Good morning, everyone. Please tell me when my screen is visible and if you can see the presentation.
Yeah, it's visible. Yes. Good luck.
Okay.
So you have 12 minutes.
Okay. So today I'm going to talk to you about the importance of secure communication. I would like to start by defining the context because this is the most important thing. Why do we need a secure communication procedure? As of 2021, we have that electronic communication is a normality, especially during the COVID-19 crisis. We communicate mainly electronically. As such, we have a lot of solutions for this, and I'm going to tell you why they are bad solutions. So let's see first the problems. These services are free. If they are free, how do they make immense amounts of money? Simply put, by mining user data. They extrapolate everything using statistical methodologies and create immense amounts of data that can be exploited. Simply put, if you're not paying for it, you are the product. Let me give you an example. A few decades ago, when technology was not that advanced, we have noticed Target, a US company, successfully predicting new parents that are going to have a baby, and they deliver targeted ads. Since new parents spend about £5,000 on baby items before the child is born, to a population of millions, this is considerable profit. However, you might tell me that this does not hurt you because we are talking about targeted ads. Let me give you a practical example. Google provides us with the possibility to ask them to give us everything regarding our data. This is an example from my personal data given to me by Google. As you can see, this is a location history of the exact latitude, longitude, address, and how much time I've spent in that particular location. I do not know about your opinion, but this horrifies me. It's absolutely terrible. And especially considering the fact this goes as back as 2016, when I was 15 or 16 years old. You can see that this data in the hands of a malevolent person is going to be disastrous. Since I hope I have convinced you and hope I didn't scare you regarding the dubious practices that happen, you might tell me that this data is safe. It is not safe. The only data that is truly safe is the one that is not being kept. The user will never be certain of the data they have. And we have to prove this by the simple fact that we have had numerous leaks regarding this. Facebook, for example, has had a ton of problems regarding this. Now, given the fact there are solutions for communication, Facebook Messenger and WhatsApp. As I have told you, problems have already been there legally, morally, ethically, all of them. Besides that, the code is closed source. That means we can't know what's happening in there. Even if they tell us everything is okay, it might not be. As such, Messenger and WhatsApp are terrible choices for privacy. Telegram, it's very popular nowadays. It's hailed as privacy friendly and open source. It is not. The server is closed source, and again, the same problem is posed. Signal. In my opinion, in my personal opinion, it's one of the only slightly viable alternatives. But they force us to use personal data, a personal phone number, which is not okay. The only thing that should be required for secure communication over the internet should be an internet connection. Moving on, before I talk to you about my proposed approach, I want to talk to you about OpenPGP. I'm going to make a strong assumption that the audience is aware of how public key cryptography and the mechanism with public key, private key, and signing works. And as such, I'm just going to tell you that OpenPGP is a hybrid system using public key cryptography and symmetric cryptography, and that it has been around for decades, and it has been used in electronic mail mainly. What is my proposed approach? I propose a full implementation of the client application and a server application, because if we do not have both of them, we cannot be sure. Just as with Telegram, we can be sure that we are truly secure. What are the advantages of the proposed application? Well, we have full control over our data. A lot of applications use this public-private key combination. However, they do not give us the control over the keys. The keys are our own data. We should be able to do with them as we see fit. The usage of the consecrated protocol also means that the person using it for a long time for electronic mail can easily migrate to the application. We provide advantage from identity validation point of view. A key pair identifies a user much better than a phone number. We have all changed phone numbers. It's rarely we need to change the public and the private keys used in a crypto system. Naturally, the most basic requirement, lack of plain text usage. Now, the OpenPGP is a template. It defines multiple protocols, multiple algorithms, and I'm going to go very fast over the ones I have chosen and why. For symmetric cryptography, we have chosen the advanced encryption standard, and for asymmetric cryptography or public key cryptography, we have chosen RSA. Both of these are not feasible to be brute forced. This is not possible with the current technology, assuming we do not make any proposition regarding quantum computing. This is a development domain, and it certainly has some potential towards cryptography breaking, but we can't make any assumption at the moment. Naturally, these are historically important. They are acknowledged even by the United States government and used for top secret information. Hashing and compression are also necessary. For hashing, we have chosen the SHA algorithm for the simple fact that it's, again, recognized and used even by the government. And for compression, the protocol recommends zip, and that's why we have used it. Technologies. What does the proposed approach use? First off, the most important thing is that we use entirely open source tools. The reasoning for this is that what I have mentioned before, if it's not open source, we don't know how it works, we don't know what happens to our data. This is why we use Android. It's the most used operating system in the world, first off. And second off, at its core, it's open source. The user can have a custom distribution of Android running on their device. As such, they are much more secure. For the Android application, we have used multiple libraries. We can go into details when you can ask questions, but the most important thing is that we have used the STOMP protocol for fast messaging. And for encryption, we have used the traditional API named Spongy Castle. For the server side, it's quite simple. It's a Spring server for the simple fact that, again, it's open source and widely used. Okay, let's talk about the application itself, because I'm promising to you a lot of things right now, and I want to keep my promise. First off, when the user registers, we can see that we require username, password, and email. However, the password is not going to be stored because it's not necessary. Storing the password is a security concern. If the password is only in the user's head, it's harder to leak it. For the simple fact, we perform a validation. I hope you can see my cursor right now. So taking a validation message, encrypting it with the public key and decrypting it with the private key and the password, if the result is the same message, then the combination is valid. This is a simple procedure, but it's much more secure than storing the password. However, on the server side, the server is not supposed to trust the client. Why should the server trust the client? Since the server only receives the public key. Sending the private key over the internet is a great mistake. Since the server only has the public key, the server will encrypt the message and it will send it to the user. If the user can decrypt it, that means he is the possessor of the public key, the private key, and the password. And as such, finally, the server can indeed trust the user. The login is similar, however, no communication is done with the server. In order, CRUD operation, what do we mean by CRUD operation? Contact addition, for example. In order to communicate, we need a username and a public key. There are some things which would be worth mentioning here, but they are extra, so to say. For example, functionalities such as blocking. We can go back to them if you will, but the most important thing is the communication. Here we have the bread and butter, if you will, of the proposed approach. What you see, the plain text that you see, is not going to be stored anywhere. Everything that is going to be stored and everything that is going to reach the server is on the right-hand side. That's what the server sees, and that's what is going to be stored in the database. The decrypted messages are only computed at runtime, for the simple fact that they are only needed then, and if we have them anywhere else, that's a security concern. So plain text information must be fully volatile. So in order to achieve secure communication. Again, another thing worth mentioning is that if we only send one message from the client to the server, we can save it. Because if I encrypt a message with another person's public key, I won't be able to read it myself. So we send two. One of them encrypted with the recipient public key, and one of them encrypted with my own public key, so I can decrypt it later. You should have concerns. Because it's foolish of me to talk about a security without talking about exploits. First off, key leakage. This is a problem in the client application because we store the private key. However, it should not be a problem of a privacy-conscious individual, for the simple fact that a privacy-informed individual will know not to install malware on his device. And this is the target audience, persons that truly want to communicate securely. However, an advantage, a blessing, and a curse, if the password is lost, everything is lost, unfortunately. For scalability, we need to talk about extensions. Currently, we do not have thousands of users, but we might have. We can implement a server cluster. As such, each group of people is going to deploy their own server. And we can implement a master server that only routes messages and does not save anything. For the client side, we can add encryption, or we can generate quick response codes based on public keys, so we can make exchanging easier. For example, this is a public key embedded in a QR code, which could be scanned. But this is future work. Let me conclude this by asking, has the problem been solved? It depends. The problem is complex. We have technological, ethical, legal concerns. It's complicated. And attackers will always become better. However, given the fact, given what I have presented to you today, I think we can safely conclude that privacy is still an option, and a proposal has been made regarding how communication systems should be. So no plain text data, a lot of validation, and truly private conversations. For this, we have delivered the client application and the server. This is a selective bibliography because so you know exactly what I was talking about in case it's interesting. And I want to end this by saying thank you for your time and thank you for everything. And hopefully we will all look forward to a better communication than what we currently have. Now, if anyone has questions or if they want to see a demo of the application, I am here.
I have a question. So as far as I understood from your presentation, the roles are a bit interchanged. So in order for the power to get back here to the client, you say that the private key should be with the client and the server should not save anything. But how does that work in a world where we are based so much on the cloud?
Well, I can say that there are various answers to you. First off, we have the uninformed user that is going to use public cloud services, and practically it invalidates my solution totally. And we have truly privacy-focused individuals that are going to have their own servers if they want cloud. They can deploy it using Raspberry Pi or using Linux, a Linux server, which is again a Raspberry Pi if they want to. But currently public services are not to be trusted, and as I have shown you with the Google example. Does that answer your question? Should I reiterate?
No, it's okay, because I'm always asking my students, okay, what solution for saving your data do you have from this perspective as well? And many of them are telling me I'm saving everything on the cloud. And I thought that I'm more traditional by saving it on external hard drive or something like this, but yeah, the problem is there.
Yeah, you know, you are secure. You are not traditional, you are secure.
Okay, thank you for the presentation. If there are any other questions?
I have a questions. You have a slide in which you have on the left side and on the right side the actual data send and what this one. So it seems to me that in your client you send something to Bob message or something like that. You send something to Bob. If everything is encrypted in the server, how can you be sure that it's exactly the Bob you expecting there at the other part of the message?
Yes. Naturally, this is a great concern. But as I have told you regarding the CRUD operation, when you import the public key, the public key can be validated. For example, we have public servers with keys. For example, the Ubuntu key server, we have keys there, and the keys can be verified by other users. That's one thing. And the other thing is the simple fact that we can get it from the person itself. For example, I go towards one of my potential communication partners, and they give me the public key. If they gave it to me, I'm going to assume it's okay. This is an argument. Another argument is that these public key servers have certain protocols in order to verify the identity. For example, I can verify other people's public keys in order to provide an extra degree of credibility. Your concern is valid. It's not going to be perfect, but consider the only perfect way of doing it is getting it from the user himself in real life. And this is a limitation that with the current technology, we can't really tackle perfectly, but we can provide a higher degree of certainty.
And your solution works only in Android and not in iOS?
Naturally. iOS is closed source. We cannot trust it.
Okay. Thank you.
Thank you.
Other questions? If there are no other questions, we will try again with Vlad Petrean to present his paper.
Hello everyone, now you can hear me?
Yes, we can.
Okay, great. So hello everyone, my name is Vlad, and as you can see, my presentation is entitled LSTM versus Arima, a time series forecasting comparison. So nowadays forecasting is everywhere, in almost every domain. In economic we have stock prediction, in medicine we have patient prediction, and even in sports we have prediction when we are talking about betting especially. And of course there are many ways to do it. We may use classical models or more recent developed one. But the question which remains when we are confronting with a prediction problem still is what's the best way to do it? So as a short answer, it depends. It depends on a lot of factors. For example, the available data, which we will use to train the models. Also, it depends on the period of forecasting. We can make long, short predictions or long predictions or short time predictions. And of course, the hardware available. So reaching the topic of this presentation, we have 4 different scenarios represented by 4 different data types. The first one being the Amazon stock evolution, the second one Romania COVID-19 evolution, Bucharest average temperature, and a number of hospitalizations for local hospital in Cluj-Napoca. And based on these 4 data sets, we will train 3 models, namely Arima, Arima, and LSTM, and study their behavior to see which one is better for every situation. And these are the 4 graphical representation of the data evolution. In the left upper corner of the screen, you can see the COVID-19 evolution. The second, in the lower part of the slide, you can see the Amazon stock evolution, the number of hospitalization, where you can see a lot of fluctuation, and of course, the Bucharest temperature. As you can see, all the data sets have a different structure and different data evolution. So in order to use these data sets as an input for the models, we will use a time series. What a time series is, basically, it's a data set which is indexed by a time column. From the component point of view, a time series is made of trends, seasonality, cyclicality, and irregularities. After we have the data in a time series format, we will need to validate its content. Why we do that? In order to make sure that we can obtain some predictions on it. And in order to do this, we'll apply the Dickey-Fuller validation. What this test does, basically, it tells us if a data set, if a time series is stationary or not stationary. So the Dickey-Fuller will give us the value of P, and if this P value is lower than 0.05, then the time series is stationary. If not, then it's non-stationary. Here in the right part of the slide, there are the original Dickey-Fuller test results, and in some cases we need to normalize the data sets. Why we need to know if a time series is stationary or not? The classical models, especially Arima and Arima, prefer to have an input as a stationary data set. What a stationary data set is, in this case, the data set can be represented by a formula, or so to say. For a non-stationary data set, then in this case it will be harder for a model to predict data. It will present worst results. Going on a little bit about each of the models. Arima model, well, basically this model studies the relationship between the records and also study the irregularities one point of view. From a structural point of view, Arima is composed by 3 models: the IR autoregressive model, the moving average, and the integration one. As Arima represents an extension over Arima, what does this model contains? It's a seasonal component which help us to notice the seasonality component in a time series. And the last of the models, LSTM. This model is part of the recurrent neural network. So being a recurrent neural network, it's able to change its initial assumption based on the data set used for training. From a structure point of view, an LSTM network is made of 3 gates: the input gate, the forget gate, and the output gate. And each of these gates are activated based on a sigmoid function, which decide what information is stored and which one is dropped based on the information input and weighting. Now that we have the models, we need to instantiate them. In case of Arima and Arima, we have used the ACF and PACF functions. These functions will give us the graphical representation of the data set's evolution from the relation between records point of view. And as you can see in these images, the point where the graphic intersects the OX axis, it will give us the parameter for IR model and for the moving average model from the previous slides. So in this case, for the number of hospitalization scenario, both of the arguments will be 1 value. In case of LSTM, well, here we didn't have, so to say, parameters in order to instantiate the recurrent neural network, but we had to give the number of generation and the data batch for each generation. and these numbers were obtained by trying several attempts. So this is why I presented here that it was a little bit of headaches for LSTM to be instantiated. As a result validation, we have chosen the mean absolute error and the root mean square error. Mean absolute error is used especially when we want to evaluate the mean of the error of the forecasting, and the root mean square error is used especially when we want to make sure that our predictions are presenting the correct value also when the data presents irregularities. Here are some of the results. Some of them are great, some not so, and we'll continue to talk a little bit about each of the scenarios. So for the Amazon stock data set, the best results were obtained by Arima model. It was a little bit surprising because this model, it seems that it observed best the continuous evolution trend of the time series. And to be honest, I was expecting the LSTM model to obtain it the best results. Going next for the Bucharest temperature data set. In this case, all of the models obtained best results, good results. This was due to the data quality, and from all of them, LSTM ranks first in terms of root mean square error, and Arima ranks first in terms of mean absolute error. For COVID-19 evolution, here the results were not so good. This was due mainly to the quality of the data. We all know that over the weekend there were not so many tests, and in the middle of the week the number of them increases. And also here the best results, so to say, were obtained by LSTM from both root mean square error and mean absolute error point of view. And for the last number of for the last scenarios, here we also had a smaller data set, namely 120 records, and also in this case LSTM obtained the best results. So as a conclusion, we have shown how each of the previous models behave in 4 different situations, and also we validate the results based on mean absolute error and root mean square error metrics. And for the specific data sets, we observe that when there is a continuous trend evolution, the best results were obtained by the Arima. In case of a large data volume and where our repetitive cycle property like the Bucharest temperature data set, LSTM achieved the best results. And in the cases that the data sets didn't present such quality in data, then it's harder to obtain accurate results. But also in these cases, LSTM also obtained the good one from the bad results, so to say. Thank you for your attention, and if you have some questions.
I have questions. You mentioned interesting results related to prediction of time series, but where or how it's how you get through the time of the interval, the time interval of this prediction. So maybe the performance is different if the time interval is small, medium, or large, or something like that. And also, I think that this aspect is important for time series or data set which have all sorts of cycles inside them, like maybe COVID-19 or something. Can you?
Yes. These presented predictions were made for long, short period ones, and in this case, and for the long period one, the results were mainly the same.
But the short period means a whole cycle or less than a cycle.
Less than.
Let's say we have we saw less than a cycle. Yes.
Yes.
Okay, just the trend.
Yes.
But also, I think that the trend is also important, at least for for, let's say, Amazon stock price or data sets which relates to stock exchange, or even if the value it's not correct, I try to pay more for some methods which give me a better trend. If they say that he will increase in value, even if the increase it's not what I expecting, that will always mark as a good prediction, in my opinion.
Yes.
Some other questions, if there are. Otherwise, maybe we can go further.
Okay, thank you. Thank you very much. Next is CARDA edit with information extraction and formal concept analysis in pharmacology.
Yes, hello, I am Edith. And I will start my presentation.
You have 12 minutes. Good luck.
You can see my screen, right?
Yes.
Okay. Now it isn't working. Yes. Okay, so what was the scope of my project? I had data for food interactions, like this example where we can read herbs that may attenuate for, yeah, so basically we have different drugs, and if we take them, we can have food interactions. The scope of this project was to extract the food names from these interactions, like here in the example, and visualize them in a graph. First, I had to do a data cleanup because the data was, it was from drug bank, but the sentences were long, and there were also multiple sentences for one interaction. And in the first phase, I split the sentences and made separate entries. So here we can see that the data after sentence splitting, showed in orange, had fewer words. Further on, yes, and everything I did was made in Python, and I used some libraries for data processing and natural language processing. There is Spacey, a library for natural language processing, which has the possibility of entity recognition, which means that it recognizes entities like geopolitical entities, places, dates, and so on, but it is really poor on food entities. That's why I chose to take an existing English language model and train it further to extract, to recognize food names. And for this, I used two training data sets, one from FoodDB and the other one from Food Data Center, and I also tried to combine the two. In the table on the right, we can see the count of the initial entries and the final entries I used, because as we can see here below, the entries weren't always distributed evenly. So the first FoodDB had lots of 1- and 2-word food names, but just a few 3-worded food names. And the Food Data Central had lots of 3- and 2-worded foods. So I had to distribute the data. After this, I split the data into training and test data. and also taking account the number of foods. And I had to prepare the data. I had to prepare example sentences where I introduced the food names from the data as shown here below in the example avoid haddock, and I had to label the food entity. Further on, I also had to prepare revision data. This is needed in order for space C not to forget the old entities. Because if we just train a model on our new entity, on food, for example, then it will not be able to recognize the old entities it was trained on. So I also had to train it on the existing entities. For this, I used another data set from United Nations General Debate Corpus. Here I also put an example sentence where I marked the entity, the recognized entity with the old model, and some results. So the table shows the entities recognized in the training data and the test data. Here is the evaluation of the test data through the test data. The first table shows the precision of the model on the food entities. Here, all the three models scored really highly. And the second table shows the performance on the old entities, where I would remark that the original precision was also around 80-something%. And here is the evaluation on the real data, which isn't as high as with the test data, but here I used the data I wanted to process from DrugBank, and the best model was the one from Food Data Central, and this is the one I used further on to generate the graphs with 63%. For the data visualization, so the first table shows an extract from the processed data. This is what the model generated. We have in the first column the drug ID, in the second one the long description, and in the third column we have the extracted entities like milk, calcium containing dairy, iron, aluminium salts. The second table is a generated concept, which is then used for more concept analysis to generate the graphs. Here we can see the column names are practically all the food entities these drugs have, and it is marked with 1 if they have it and 0 if not. And now I want to show you a short demo. Here is the application where I can introduce some drug names. And if I introduce it wrongly, then it should give me some possible correct solutions. And this is the graph which is generated. Here we can see the drug names. And in the upper part, the food interaction, basically the food entities. So here we can see that these two drugs have one in common. And basically, this first drug has vitamin, avocado, green vegetables, these two, and so on. I can also show a second example if you want. Or I don't know, I didn't track the time, if I still have time.
Yes, you still have 3 minutes.
Okay, then I will show you a second one. So here I used 4 drugs, and we can see that the graph is a bit more complex. But this part, for example, is not completely right. There is still room for improvement on the model because, as you can see, it also recognizes the drug name. Possible improvement would be to also train the model on drug names. And further on, we can see that we have here grapefruit, also whole fruit and juice rand. This is because also the descriptions are not structured, and I checked the food interactions for this drug, and there were 3 entries stating basically the same thing, that it had an interaction with grapefruit. So yes, the model could be still improved, but this is a short presentation of the current research I did. I think I am done with the presentations. Are there any questions?
Thank you, Karda. So for this final presentation, did you use the FCA bundle tool that you have, or how
No, so I used the library from Python to generate the concepts. I basically made a REST API where I can also show you. So I made the REST API where it sends the generated concepts in the form in which I can visualize them in my Angular application.
Okay. So how did you come from the results that you from the artificial intelligence results to the concept?
So in the first part, as I showed in a short example in the presentation, I had the data in a CSV file where I had the drug IDs, the descriptions, and the generated food entities, the food names. And if I have, for example, 3 drug IDs, I parse the file, get the food entities, and construct the table I showed in the presentation with the concept. And after that, I use the concepts library from Python to generate the concept lattice, which I also prepared in JSON format, but the format which is compatible with the Nginx graph library from Angular, which I used to visualize the graph in the Angular application.
Okay, thank you.
And a question from me. So you didn't use any kind of ontology here. So you don't have something to say that some drugs are antibiotics and some other are from another family, or?
So I also have information regarding, for example, the categories of the drugs, but I didn't use them for the graph visualization, but I could expand it. Or I don't know if I answered the questions. I didn't use ontologies.
I think that's in a way kind of answer to my questions. If you use the information which groups together more than one single instance or more than one single concept inside the more general concept?
No, I just grouped them on the food interactions. Basically, on the food names I extracted. Because here in this example, I showed you just 3 or 4 drugs, but the graphs were already kind of complex, and we can imagine that a person already takes 7 drugs and gets other 3 prescribed, and then the list of food interactions gets really long, and this would be a better way of synthesizing the information and having a clearer view on it.
Thank you.
Thank you. Thank you, Ed.
Thank you.
I think that we can continue maybe now. And if I'm correct, the next paper is presented by Câmpean Adelina Ioana, test package for stress and fatigue detection.
Hello, I am sharing the screen.
A little bit louder, if it's possible.
Okay. Hello and good morning, everyone. My name is Adelina Ioana Câmpean, and I am a student at Technical University of Cluj-Napoca at Computer Science. This article is based on the test package for stress and fatigue detection made under the guidance of Professor Gheorghe Sebastian Pal. In the following, I will present the field in which this article falls, the reason why I chose this topic, and after that I will continue with how the application was implemented in the analysis and design part, then what are the experimental results obtained, how they were evaluated, and finally I will end with the conclusions. I present the quality and efficiency of human activity and how it is significantly influenced by the subject stress or fatigue state. The main goal of the present project was to find a set of test scenarios that may reflect the state of a computer user. The behavior parameters extracted from this test are used to classify the state of a person as normal or abnormal under stress or fatigue. The developed framework would be useful for persons working in critical environments or for those who has to perform critical tasks. The experiments performed on the developed tests this demonstrates that the classification of a person's state is possible through the proposed methodology. This topic was chosen because stress is a state that every person has in a regular period. It is a normal reaction which sometimes can be positive and helpful because it's keeping the brain alert, focused on and always ready to avoid danger. But there is a fine line between good stress and harmful stress. It's starting to damage the body if the stress is continuous and without periods of relaxation. When stress is usually present, the abilities of the person in question are considerably diminished because his energy is concentrating on involuntarily feeding the stress to the detriment of performing the necessary activities. The process of detecting the level of stress that a user has consists in a running desktop application made with different scenarios. Each test has a few parameters that need to be fulfilled, and depending on them, the classification algorithm it will be able to give an answer. Before each test, a message will appear on the screen with a short description of the test the subject is about to take, how are they going to be, and what the user should do. The application contains 3 major test cases, a randomly moving ball, a maze test, and correctly pressed keys. The main challenge of the project was to extract and evaluate a set of parameters that are relevant for classifying the state of a person. The first scenario of the application contains a ball which moves randomly on the screen with different speeds. The user has to follow the ball using the mouse, and he has to concentrate on keeping the mouse as long as possible to that moving ball. The ball speed changes every few seconds to make it harder to complete and to put the user in a higher difficulty. As can be seen in this picture, the red line represents the subject mouse and how he managed to follow the ball, and the blue line represents the path made by the ball. The second test is made mainly by a maze, such as the one in the figure 2, and the subject at first it is supposed to find the way out of it. The user also has to find the best way possible, the shortest one, because not any solution represents a good one. Besides that, in this scenario, it is very important how the subject goes through that maze, how hard his hand shakes on the mouse, or how constant it is the line drawn through it. The third scenario is based on verifying subject attention. On the window will appear letters in a random order, and the user is supposed to click on the keyboard the letter he sees on the screen as shown in figure 3. In the real application, only one letter is on the screen at a time. The picture has been modified to be more suggestive. The further the user goes into this scenario, the faster the letters appear and the less they stay on the screen, in order to make the users work harder. The scope of this test is to check if the user can memorize the letter he saw and also can press the right one at the right time. The first experimental results were obtained in the first scenario where the subject had to follow the randomly moving ball. The first parameter saved from this scenario, it is the counter which calculates the seconds when the user keeps his mouse on the same position as the ball. In figure 4, it is present a graph made from this parameter which contains the two states of the subject, stressed and relaxed. The blue line represents the case where the subject is stressed, having lower values, because he failed to keep the mouse on the same position with the ball for a long time. The orange line represents the case where the subject is relaxed with higher values because he managed to keep the mouse for the same position with the ball for a long period of time. After that, the following results were obtained in the case where the user has to press the right keys. The most important parameter taken from this test is how many correct answers the user has, how many letters he manages to press according to those displayed on the screen. Figure 5 contains a graph in which it can be seen the two states of the subject, stressed and relaxed. As mentioned before, the blue line represents when the user is stressed and the values are lower because the user cannot keep up with the letters displayed on the screen, making more mistakes. The orange line represents when the user is relaxed and the values are much higher because the user is able to press more letters correctly. These results are based on the scenario containing the maze. The focus is on retrieving the information about the line drawn by the user in the maze on which was applied the fast Fourier transform. In figure 6 are shown the two graphs of the Euclidean distance representing the two user states. The one drawn with the blue line represents the relaxed state of the user, and the one drawn with the orange line represents the stressed state. As can be seen, the stressed one has higher values because they are based on the line drawn by the user, and in the stressed case, the fluctuations are bigger. In the relaxed case, the user is closer to the ideal path, so the values are lower, as are the fluctuations. In figure 7, the two graphs of the FFT are displayed representing the two user states. The one drawn with the blue line represents the relaxed state of the user, and the orange line represents the stressed state. As can be seen, the stressed one has higher values and bigger fluctuations because the line drawn by the user in a state of intense stress is much more imprecise and much longer compared to the relaxed case. The evaluation was made using K-means algorithm for classification. The entire evaluation process was carried out on 3 subjects, each taking a set of 5 tests. Initially, participants were subjected to the first test in a relaxed period, representing the relaxed case. After that, each participant was subjected to stressors, the second test representing the stressed case. The next 3 tests were performed at different times of the day or week to check the condition of the subject. Overall, there were 15 tests performed, of which 3 were not relevant. The answer was expected to be one type, but it was the other. The accuracy of the application is somewhere between 75%. The relatively small number of experiments, it is because the project has only recently been completed and is due to be tested more intensively in the coming period. To conclude all that has been mentioned, this article contains an example of an application that can detect and measure the stress state of the user under certain conditions and from certain points of view. The application works best if all tests are performed on one person, and the application is more effective than other methods that use surveys and approximately as effective as method using sensor. Thank you for your attention, and if there are any questions, I am willing to answer them.
So, what it is relevant, the number of experiments. You managed to do only 15 experiments, 3-person, 5 tests, and in the end you come with an observation that it's better if there are only one single person. But in my opinion, I think that my main observation, my main questions will be how can be this data can translate from one person to another person. Maybe the stress is not the same in different person.
Yes, the stress is different, and that's the reason why I said at the end that if all the data are only for one person, the accuracy is better. Because firstly, I tested only on myself, and the results were the best, because the algorithm was trained only with my state of stressed state and relaxed state. If the user are different, I had to put a few tests for each person before testing a random state of a user. So the algorithm have information which he can group to obtain an answer.
Maybe some person works best with a mouse, other works best with the keyboard, and maybe the level of stress are different if they have different tests in which they use mainly the mouse or to follow the ball or the keyboard to press a letter, a key.
Yes, I tried to incorporate in this scenario both the keyboard and the mouse to cover these cases. When a person is more familiar with the keyboard or more familiar with the mouse.
And the last question is that maybe, in my opinion at least, I think that the best way is to use not a keyboard, not a desktop computer, but maybe a phone, a mobile device. Maybe it's more interesting and you have more option to test the interaction and the level of stress in different person with mobile device.
Yes, I think the application can be improved by switching the application on the mobile devices and adapting the scenarios to the mobile.
Okay, thank you. Other questions if there are.
So did you use artificial intelligence algorithms? Because you said at one point that the algorithm was trained only on your experiments.
For classification, I used the K-means algorithm. I didn't use artificial intelligence.
Okay. And can you go back in your presentation to the slide where you showed the figure 4 and figure 5? And maybe you can detail what we can see on the y-axis.
On the y-axis are the values the user had. The number in this case, in figure 4, it's a counter that calculates the seconds. And the y values represent the milliseconds of each value. And on the figure 5, the y-axis represents the number of correct answers the user has. The correctly pressed letters. The number of the correctly pressed letters.
And on the x-axis?
On the x-axis is the number of tests. It was 15 tests on each test.
Okay. Thank you.
Thank you.
Okay, I think that we can
Yeah, we can go on to the author Posa Dorel Gabriel will present a complete pipeline for managing and analyzing sensor data using cloud solutions.
Hello.
Hello, you have 12 minutes. Good luck.
Thank you. Okay, my name is Dorel Posa. My project is called the Complete Pipeline for Managing and Analyzing Sensor Data Using Cloud Solutions. First of all, the motivation. Why we need the Internet of Things? Well, we have sensors that analyze and gather data from physical phenomenon and translate them into electrical currents. These currents are then analyzed, categorized, shown in dashboards, in charts by the IoT. And we humans can then see this data, interpret it, and use it to improve the system. For the related work, TeamViewer and also IBM Watson have their own IoT platforms. TeamViewer's IoT is mainly used for remote control. There is an agriculture machine building facility that successfully used TeamViewer IoT. And IBM Watson's main point is the use of machine learning to analyze the data gathered by the IoT platform. And also they show the data that was analyzed in the last 30 days. The architecture for the generator. Well, the generator is an API that writes custom APIs based on a JSON structure. How it was designed is that, first of all, an API was designed, a basic one. The fields that are based on the entity had to be found. Once these fields were found, these were the actual parameters that needed to be passed to the generator. And after we have this, we have a template, let's say a very long string that has placeholders in it. After we fill in these fields, we're going to have a functional API. And the values that you need to pass are the entity name. That's going to be also the name of the model. Mongo's username and password, because the data will be stored on MongoDB, an online cloud platform. Also the cluster name. And the attributes that the API will have, the model. For example, here for the accelerometer, we have the XYZ value and also a key that is used to uniquely identify each document. The endpoints that the API needs are get, post, patch, and delete. In my opinion, these endpoints are enough for the proof of concept. The databases used were MongoDB, firstly, because MongoDB provides free cloud storage, and the main purpose for this application was to only use free solutions. MongoDB also provides dashboards for the gathered data, and the next database used was Elasticsearch. Elasticsearch was only implemented for, let's say, a backup. Elasticsearch doesn't provide free cloud storage, but together with a local database, Grafana, another service that generates very impressive and beautiful graphs and charts, could be used for further work to further have the visualization component of the data. The APIs, also the generator and the generated APIs, needed to be Dockerized in order to be used by any user and to be posted on the Heroku cloud. Heroku is a free deployment service. I used Heroku to deploy the generator. Together, to the generator was sent, JSONs were sent in order to generate the APIs. These APIs were then also deployed to Heroku and were used for the proof of concept. GitHub was used to store the generated APIs on the cloud. For each API, there's a new folder. The deployment view of the application looks like this. First of all, the heart of the application is the Heroku server, on which we have the generator and all the APIs for the sensors that were used for the proof of concept. The generator works together with GitHub, and a smartphone sends data to the accelerometer and gyroscope API sensor. Arduino Explora was used to send data for temperature and light sensor, and then MongoDB stores all this data and uses dashboards to display it. For the proof of concept, the accelerometer and gyroscope sensors from my Android phone were used. With this data, we can draw a graph of the speed in which the phone was moving, the acceleration over a timestamp. And with the Arduino, we can see how the light progresses throughout the day and the temperature also. I'm gonna demonstrate how the generator works. We're gonna send data for a proximity sensor, and the proximity sensor only sends the distance. Now, if we look on GitHub, we can see the proximity sensor. The proximity sensor has all the files necessary for immediate Heroku deployment, together with the API that has all of the API endpoints. The timestamp, which is important for the analyzing component, is saved here in the post, and also the model, which is the class. And I have here a little Arduino. I have a little Python script that sends the data to the APIs. I'm gonna start it. And on MongoDB, here we have the charts. I have here the light sensor and the temperature. I'm gonna refresh it right now. It may take a bit of time. Okay, currently light is at 980 lumen, temperature to 23 degrees Celsius. And if I cover up the light sensor and we refresh it again, it should display a much smaller value here. And that's it. Thanks for your attention, and I'm open to questions.
So can you explain a bit more the graph on the right-hand side?
Yes. This one?
Yeah.
Okay. The acceleration is calculated from the accelerometer using a formula, square root of x squared plus y squared plus z squared. And it shows when the phone was shaken. That's when the acceleration increased. And when the phone was sitting on the table, there's no change in the acceleration, it's constant.
And another question, because you had like an opposite approach to one of your colleagues who had a security concern and who just told us that it's not safe to use the cloud, and your solution is using the cloud. How do you see this security liability of sharing all your data to the cloud?
Okay, momentarily, because we don't know from which IP Heroku sends the data. I had to whitelist all the IPs for MongoDB, so everyone has access to this data. But that can be changed. For example, if a client uses this application, we can only have his IP whitelisted. In my opinion, it's very useful to have the data on the cloud, because it can easily be accessed by many parties which can use it to get to, for example, see anomalies.
Yeah, or maybe inoffensive data that collectively can get us an answer which does not impair the privacy.
Yeah.
Thank you.
Thank you.
Other questions?
I don't have any question.
Okay, thank you. Thank you very much. We can move on.
Thank you. And now the next, we're so much ahead of time that we have time in the end for another presentation. I think that with 50 minutes before their allotted time, Anna Rednik, Septimio Crișan. Let's see.
Hello.
Hello.
So I can start now?
Yes.
Hello.
Design and implementation of a marking assisted guide robot for art museum.
Yes. Hello. My name is Anna Rednik, and I'm going to present a solution for automated guidance in an expositional space. In an environment oriented to technology, statistics done by the Art Museum in Baia Mare have proved that people show less interest towards visiting museums. Instead, they are attracted by activities that imply technology, like virtual tours or virtual expositions. So, a potential solution is to increase the number of visitors in museums using technology. This project proposes an autonomous robot that can make guided tours in a museum, solving the problems related to finding specialized museum guides and relieving them from their busy workload while assuring non-stop guiding. The robot should be able to work with individual visitors or groups. It should be autonomous in order to navigate through the rooms and detect the room in which it arrives, while paying attention to possible obstacles. And because visitors come from a multicultural background, they should be able to choose both the language and complexity of speech. Of course, this is not the only concept in the world. There are others. But according to the director of the museum in Baia Mare, there are no other robots like this in Romania. The ones presented on the slide use various algorithms to orientate themselves in dynamic environments. The most advanced robots have predefined mapping of the surroundings stored in memory, or generate a live map using cameras and laser sensors. Some of them are based on technologies like SLAM, simultaneous localization and mapping, optical flow, or odometry based on movement coordinates. The ones presented use speech synthesis and gestures to interact with visitors while showing a user-friendly interface. During research, two main categories of features were studied and compared: motion and communication with visitors. Most of the robots use whole-range cameras and distance sensors, but as we can see, the safest way is to already have a predefined mapping of the environment stored in memory, besides the one created on the fly. For the interaction part, they have touchscreen displays and are also able to move parts of their bodies, which makes the experience more realistic. For the proposed solution, specific objectives have been set. The museum will have a line that goes from one end of the exhibition to the other, and the robot should follow it. Because visitors move around, the robot may encounter obstacles. In such cases, it should stop and signal visitors to clear its path. The robot will have a relevant speech for each room, showing its translation on a display. At the end of each tour, it should return by itself to the charging station, although the battery could last for a whole museum day. The block diagram of the proposed system has three main modules. The first one serves the movement, controlling two motors through an H-bridge. The second one directs the robot using line, distance, and color sensors. The third one allows the information to be presented in visual and audio form to the user. In an art museum, the temperature and humidity are monitored every hour. Having an environmental sensor attached to the robot could ease the monitoring activity by determining when there are great oscillations in parameters. The robot has a series of custom-made algorithms. The line following algorithm receives readings from a line sensor. If the central sensors are detecting the line, the robot continues to move straight. If the right sensors detect the line, then the robot should take a left turn. Accordingly, it happens for the left sensors. When visitors cross the robot's path, it should stop and continue only when its path is clear. If an obstacle stays in front of the robot for more than 5 seconds, it will play a speech kindly asking visitors to move aside while giving light signals. In order to identify the room in which it arrived, first it detects a perpendicular line, then it slows down and reads a color. After detecting the color, it plays the corresponding speech for that room. Some of the components used in the robot are presented on this slide. For the motion and the sensing part, we have a dual-channel motor driver, an array of 16 line sensors, and a color sensor composed of 64 photodiodes with red, green, and blue filters applied. Obstacle avoidance and environmental measurements are done using these types of sensors. The robot uses a dual controller system composed of an Arduino Micro for low-level sensor connectivity and a Raspberry Pi for the visual interface and speeches. The implemented robot has a modular approach. The mechanical design of the robot has been created in SolidWorks, all the hardware modules being attached to the chassis using 3D printed or aluminum parts. Several iterations have been constructed to determine the optimal configuration of the robot. It first started with a 3D printed base, 8-line sensors array, and an Arduino Uno. It ended with an aluminum base, 16-line sensors, and an Arduino Micro. Because of an insufficient number of input and output channels in the microcontroller and due to the power connection requirements, a circuit board has been designed and populated. It contains an Arduino Micro, a port expander, and it connects to low-level sensors like line, color, or proximity. All the components are through-hole for easier debugging and implementation. The line following algorithm is based on readings from 16 sensors. When the robot departs from the set point, an error is computed and the PID value contributes to voltages of motors. The room identification algorithm starts with identifying a perpendicular line, which means that more than 4 sensors detect the line. Then speed is decreased and the color sensor begins to read RGB intensities. The color is detected by comparing readings to experimentally identified colors. Finally, the corresponding number of the room is sent to Raspberry, which will play a speech. The code for motion and sensing was developed in the Arduino environment, where separate functions were created for each algorithm. The interface was designed in the Node-RED environment, which is a programming tool that connects hardware devices to an interface. It consists of flows composed of interconnected nodes. These nodes are either functions or widgets or have other scopes. Here we can see the final design of the robot. It weighs 4 kilograms, so it's not so easy to be destabilized by children. The pyramidal form gives it more stability and also allows for a tired inside architecture, which is more secure. Several experiments have been performed on location in the Art Museum of Baia Mare in order to validate this product. First, the duration of a tour was estimated based on the importance of exhibits in each room. The software implementation was optimized depending on time measurements for each function. Hardware experiments were performed to detect the optimal moving speed of the robot, such that it will have a good control without moving too fast for visitors. The reliability of the robot in keeping the line has been evaluated by measuring the widest angle the robot could form with the line to still be able to redress. The right placement of distance sensors on the case was also analyzed so that objects with different textures and colors will surely be detected. Finally, the right dimensions of markings on the floor could guarantee a successful recognition. One test was done with constant speeds and different dimensions of markings, and one with constant markings but varying speeds. Higher goals of the project would be to focus the robot on children interaction, to use speech recognition tools for advanced communication with visitors, and of course, to make its orientation in space independent of any markings. A wireless firmware diagnosis and deployment system would be helpful in the further development of the robot. Now, as a side note, the improvements are currently under development to make the robot autonomous using movement coordinates. The coordinates are taken from an old optical mouse, and the robot also has a predefined mapping of the environment stored in memory. Tilt sensors, gyroscope, accelerometer, and magnetometer make the robot aware of its position in space. Thank you.
Thank you very much for your presentation. If there are questions.
I have a question. If there are no others, how did you come up with this collaboration with Biomare, with the museum in Biomare? And yeah, I have another following question after that.
Okay. Well, I live in Biomare, and my mom works at the museum since 15 years ago. So I know their needs. I can see what could attract visitors in the museum. And I could create this robot specialized to their needs, to their exhibition. I see they're constantly trying to attract visitors by making guided virtual tours or expositions online or other kinds of stuff related to technology. So this idea came to my mind about 3 years ago, I guess. And I'm trying to develop it to be perfect for the museum.
And aren't there some stairs involved in that museum, as I can remember? And how are you going to deal with them? If there,
yes,
my memory serves.
There are only 2 exhibitions. One is at the ground floor, for which the robot was made. It only has thresholds of 1 centimeter between rooms. It's not so problematic for the robot to orientate, but at the first floor they have a different exhibition for which different solutions should be implemented. I thought for the first floor of a drone because it's completely different. It has cover on the floor, so the robot couldn't move easily. So I thought of something in air.
It's really good that you came up with a solution that you think that it's a product that's it is very good. And my final question is, what was your biggest challenge in this endeavor?
the biggest challenge was the hardware implementation, because as I tell my students, it's easy to make a project to work once. It's very hard to make it work every time. So that took a lot of tests. Also tests done on site, because it didn't match the things I prepared from home. So yeah, I changed a lot of hardware, a lot of components. As I said, it had a modular approach. So motors were changed, the base of the robot. I thought a lot about the design, how it should be in order to be stable, to be high enough for the visitors to see what is written on the display, how it should talk so that it can be heard in the museum.
Okay, thank you.
Thank you too.
I have also questions. You mentioned it's here in conclusion that it's custom made for the art museum in Baia Mare, and you also mentioned that somehow he stored the configuration, the rooms. It's stored in memory.
Yes.
But the actual configuration changed during maybe today. There would be something more obstacle in the room.
Well, it has to make a difference between stable obstacles, which can be hard-coded on the map stored in its memory, and the dynamic obstacles, which are visitors or other people from the museum, that he will detect on the fly.
But maybe there is a furniture there in the museum. If they change the position of the furniture.
I understand. Well, that doesn't happen often, but the solution would be that that obstacle is detected every time, even if the map is not updated right then.
He detects
it will
always
detect
the new obstacle, but it does not update their map.
Yes. So for that, in time, it can check if the same obstacle was detected on the same spot, and it should mark on its mapping, which is not hard to do. It should mark that obstacle.
Okay, thank you.
Thank you too.
Very nice presentation, thank you.
Thanks.
So we can move on with Virena Nicoleta, discovering and building knowledge spaces. I know that we are ahead, but to be fair to the colleagues which were previously, you also have 12 minutes. So good luck, Nicoleta. Moment.
Can you see my screen?
Yeah, we can see your screen. If you can talk a bit louder, please.
Oh, sure.
Thank you.
Before arriving at the research part, I would like to make a short intro in this domain. The learning space theories have various domains of applicability, and they have been thoroughly investigated. The theory of learning and knowledge spaces has been applied to many learning tasks. The motivation of this article is to analyze the way knowledge spaces are formed, and using the result of two tests different from the point of view of structure, to see how these theoretical concepts could be used in the assimilation of the theoretical information. The knowledge space theory is a set of concepts and structures that aim to assess one's knowledge state. The main focus is on labeling the information, what a person can do and what a person is ready to learn in order to check if someone is capable to perform a specific activity. Knowledge space theory intends to provide a more efficient guidelines to the learner in order to master a new subject. In comparison to the ranking method, to the common method, this use units of knowledge in order to create an evaluation scale for a specific ability. The knowledge state is the main concept of this theory, and it defines a particular set of problems that a person is able to solve. Therefore, a knowledge structure is a distinguished collection of knowledge states, which is a combination of items that one individual can belong to. Sorry. Not lastly, the knowledge space is a more restricted knowledge structure. A knowledge structure, in order to be considered a knowledge space, has to fulfill the statements mentioned in the shape. So it has to contain the whole problem set, to contain the empty set, and also to be union and intersection closed. The first part of my research is based on a multiple choice test, the result to this multiple choice test. And I want to emphasize using this, the connection between the understanding of all options of a test and the chance of giving a correct answer. As you can see in this lattice, there are objects and attributes. The objects represent the questions from the first part of the test. And the attributes are the options which are shared among the 6 questions. Following the lines, we can observe, following the lines in ascending order, we can observe that there are 3 main items, item 7, item 2, and item 4, that include the correct options of other testing points, such as item 5 and item 3. Making a parallel to this, and using the results of the dataset, I can state the fact that a correct answer to item 4 implies also a correct answer to item 8. The same happens in the case of item 7 and item 5. As a short notice of this research section, the candidate has a bigger chance to give a correct answer to a question which has as options terms that the candidate is familiar with. The second part of my research uses a more granular test from the domain of photography. Using this and the construction and the ordering principles, I would like to create a knowledge space in order to improve the testing and assessing of information process. First of all, a construction principle means the assigning of components to all the problems which belong to a test. And along the 42 testing points, I could notice 6 main topics. From visualization reasons and for clarity, I translated them, each of the topic, to a component, which is a color. In this slide, there are all the items with their corresponding component or color. And there is also an additional one, the shape with the black line. This contains a collection of items which are more special from the point of view of structure. They have a more complex one. And by more complex, I mean that the items from this collection are representative for more than one component. And their case will be discussed a little bit later. After we labeled all the questions, I would like to use the ordering principle in order to have a service relation. The human experience would have been extremely useful in ordering these components by their knowledge used in order to be mastered. But this is not the purpose of this research. I would like to have an automatic process for determining the relation between the components. I evaluated more tests and the successful one was generating the successful ratio for each item, and after that sorting by this value. This gave me an intermediate result, and based on this, I created an average of all the positions in the previous list based on the component they belong to. This first step was needed because the questions in the components were not equal to each of them. Some of them have a bigger number of questions. Okay. After this first step, we received this scale in which the yellow component is the first one, which means that it needs the least knowledge in order to be mastered, while the gray one is the peak of knowledge, which will be mastered at last. The assessment of the process of learning is a sequential process, and it has to be made step by step. So this will be the order: the yellow one, the pink, the blue, and lastly the gray one. As I mentioned before, there are some special cases of multi-component problems. The mix from the attributes of the components mentioned before are seen in these three cases. And we can imagine this as these attributes are located on three different scales. And we can see these three cases as the result of a product of the three scales. There is an observation which is used in this case, that problems that are constructed by product formation can be ordered lexicographically. Using this fact, the most important components will be stored in the beginning of the dictionary, and the less important ones, which need not so much information in order to be achieved, will be stored in the last section of the dictionary. So, as a result, the questions from case 1 and case 3 will be located among the questions from the component red, while the questions belonging to case 2 will be assigned to the questions from the component green. When I say assigned, I mean that they will show in the test during this section of components. After deciding each of the component placed in the scale, we can analyze the results. We have a structure with the problem set Q with the given colors, and another set of possible states obtained by the linear order from the previous slide, K. We can validate the fact that this is intersection and union closed, and so it is a knowledge space. Therefore, we can use this knowledge space to improve our testing approach, because we can reduce the number of questions using only this order of components. This is it. Thank you.
So your conclusions and your findings?
We managed to have a knowledge space, and having a knowledge space, we can stop whenever we want the process of assessing the state of a person in the moment when someone doesn't manage to reach a specific level.
Okay, thank you. And I saw at one point that you have used a diagram which is obtained using FCA bundle tool.
Sure.
Mentioned. So what's the relation between FCA and I think what you're presenting is maybe a broader umbrella, the knowledge concepts and the knowledge spaces. Can
Yes.
you do?
They are related. In my research, I used FCA bundle to help me in the first part of my research, in the Boolean analysis part, for showing the implications between the items, because I wanted to provide a result for the idea of having a multiple choice test when a correct answer is given only by the correct options. And if the candidate doesn't manage to give a proper answer, probably he didn't succeed in choosing one option because he didn't understand that.
Okay, and then on the second part of your research, you said at one point when you associated the color with different concepts. Yes. Okay, and the yellow, as I remember, was for the color theory. So the yellow here in the multi-components problem, for instance, in this slide, the yellow still represents the color theory, and this assignation is based on the domain in which you made your test, or
yes,
or the evaluation.
Practically, I broke each question in smaller parts, and based on the terms used in the question, would make these associations.
So the question was in the domain of photography?
Yes, yes.
Okay.
I needed a more abstract domain because the first research was made in the domain of mathematics, and that's very natural for us to say which step is following the other. So I wanted something more abstract.
Okay, thank you. Thank you, Nicoletta. If there are any other questions?
So your approach, it works best in the domain of photography?
No.
Or only in photography, or in all sorts of domain knowledge?
This approach can be used in all domains because we can structure our components and find an ordering scale for them for components coming from all over the domains of knowledge. We are not limited to something. But
there are domains in which knowledge is highly structured. There is a hierarchy, ontology, or something like that. But maybe there are knowledge domain in which this structure it's less present. So maybe it's sparse. It's just a concept, and all the concepts are not at all related or interrelated, let's say.
I understand.
So what is your point? In my opinion, you cannot say that all the knowledge domain are the same. There are different type, different.
It's true. The information from a specific domain should be connected from one another. It should not be extremely isolated. The concepts from a step should be used in the following.
So your approach works best in domain in which the knowledge is highly structured in a kind of hierarchy, ontology.
Yes.
Or...
Yes.
Okay, thank you.
Thank you.
Thank you, Nicoletta.
If there are no other questions, I think that we can further continue to the next presentation. Andrea Ilieș, I think.
Yes, hello.
Understanding cooking recipe structures using grammars.
Yes, my name is Andrea Ilieș, and I'm going to present understanding cooking recipe structure using grammars. So food is everywhere in our lives, from the birth to our death, and nowadays there are more and more recipes published. So how do we know if a recipe is good or not? The solution is to find a structure for them. And I noticed that recipes usually have the same types of specifications: heat, time, location, the manner. And I arrived to the conclusion that I could use parse tree with labels. So for the labeling, I chose semantic role labeling, which is interesting because the group of words are not tagged by part of speech, are actually the answers to specific questions. For example, argument 0 is the one that does something, who does something. Argument 1, on whom. Argument location is for where, temporal for when, and so on. We also have argument 2 to 5, which are pretty inconsistent and are hard even for humans to distinguish from the others, argument M modifiers. For that, I also used two models from LN and LP, which were semantic role labeler and constituency parser. The semantic role labeler was more of a reference, and the constituency parser I used to extract the part of speech. The semantic role labeling is really interesting in the case of recipes because we can really see the mapping between different specifications and the tags. For example, here, argument 1 represents the instructions. For the location, we can definitely see that the ball is actually a location for the recipe, and the time, of course, is the time. Related work, there were existing approaches with milk and simmer, but actually milk has a very low level of granularity because it uses only the 3 primitives ingredient, tool, and string, where string is everything that is not the other 2, and it doesn't give enough details. And this is where I come in because I want more details. In my solution, I used a dataset gathered from Epicurus and All Recipes. I used Python with the libraries Beautiful Soup and Selenium. There were 45,000 steps, and each recipe has a various sentence count. Okay, so the main tools for the solution were Lex and Yak. Lex is the lexer, which receives the recipe text. It gives as an output the tokens. For the tokens, I used part of speech. So these tokens go to Yak, where the grammar tries to match the sentence structure to the ones for imperative sentences, and then gives us an output, JSON string, which is a 3 representation of the recipe. And every group of word is labeled, and we have different levels. Okay, for the Lex uses tokens. So for the tokens, we actually need to identify the words. And how can we do this? The first solution that I thought of was dictionaries, but with recipes there's a problem that every day we can invent a new recipe or a new ingredient, and dictionaries take time to update. So I tried to take a general approach, and I noticed that all these new words are actually nouns. So I only needed to extract verbs, adjectives, and adverbs. So I used LN and LP constituency parser to extract these parts of speech from a part of my database, not all the sentences, because I didn't want it to affect the test results. So I extracted verbs, adjectives, and adverbs, which are pretty constant in recipes. For the conjunctions, prepositions, and determiners, I manually added them in Lex, and the nouns are everything that was not extracted and not manually added, with a few exceptions. But there is a problem with the constituency parser because usually models are not trained with many imperative sentences, and recipes use imperative sentences. And I noticed that sometimes it would not tag a verb at all. The VB tag or VBP tag was missing. And in these cases, I could actually fix the model by adding a determiner after the first tag that was different from adverb. For example, here we have preheat oven to 200 degrees. Oven was mistagged as VBN, and preheat, which was the verb, as a noun, which is not good. So I added the determiner, and the tagging was fixed. Preheat was seen as a verb. There was also the problem of words that could be different parts of speech. For example, here is covered, which could be cover as a verb or cover as a noun, and I notice some patterns where I could use the previous tokens in determining if it's actually a noun, a verb, or in the case of a word that can be a verb or adjective, it's an adjective. and so on. But this does not always work because these rules are pretty limited, are based on observations. And I used these tokens, dual VM, VJ, for different pairs. And they went directly to YAC, where YAC uses its conflict resolution to see if it's actually one part of speech or the other. So there were specific keywords that could use in the labeling, where tool, container, and heat. Tool usually help with the manner, container with location, and heat with the extent, which is for the temperature. And I noticed that the arguments are usually following the formula of proposition plus keyword. The problem with YAC is that it uses a look ahead of one. There were some issues because it was a look ahead of one means that it only looks at one token ahead to see if it can go one route or another. And here, for example, when we had a quantity interval, we were unable at first to see if the quantity is related to time or something else. So I had to go back to lex and use regular expressions to see if it's actually time related or quantity. So every argument actually has a noun group in itself. It's a proposition and a noun group. This noun group I wrote the rules for. It's unknown PJs, I called him. And it's made of nouns, its determiners, and them itself that make an entire argument. Here we can see, for example, 3 pieces of meat and a tomato salad, how it is split. Okay. For the attributes, these are for the nouns, can be determiners, quantities, adjectives. The order for some are preset, for others not. For example, a determiner is always before an adjective. And I also use a special token, CC3, which helps with the hierarchy of coordination, because we actually have some problems that we need to set the levels for the tree. A coordination conjunction can be inside an argument, between different arguments, or between different sentences. So this helps in settling the level. The arguments do not have a specific order, so I needed to do a chain. I used the recursion. For the argument modifiers, I used the formula specific proposition plus unknown PJs. For example, put the cereal in a bowl has in and then the noun. The exceptions from this were argument 0 and 1, which usually use only unknown PJs. There are also the case where the argument can be a larger group. For example, try eating the pizza. Eating the pizza becomes the entire argument 1. Okay, so the result is a JSON tree. I chose JSON because it's pretty independent and it's good for saving. The levels are recipe, step, the verb, and the verb with arguments and subarguments. The level of details is even from units, quantity, qualities. And I needed to make a visual representation for this because it's pretty hard to follow a JSON. Even if a computer easily reads it, it's hard for a human. So I did in Angular a way of representing it. We can see this for a sample recipe. We can see the qualities, the objects, the tags, for example, argument location on the top. Here are another sentences. Also, when a number is written in using characters different from the digits, it translates them into digits. Here we can see another example. For analysis, actually, the main problem was sentence recognition because I based everything on part of speech and actually the English grammar. So there are sentences that were not recognized, about 30% of them. The main fail reasons were that the sentences in the data set maybe were declarative. For example, someone started talking about how their grandma used to do the recipe for them, which are not relevant. And sometimes the structure was simply unclear. For the I tried to make a comparison for the labeling with L1 and NLP, and I realized that they have different fail points. Mine was when I couldn't find the structure, and NLP failed at labeling. For example, here it was unable to find the verb for the sentence. Another difference based on the annotated sentences that I did for testing was that Ellen used argument 2 to 5, and I used argument modifiers for location, which are more specific in this case. In conclusion, I managed to find a way of structuring the recipes into parsing trees using grammars. I use semantic roles because they give a good mapping of the specifications. And I still need to improve the overall sentence recognition, but this methodology can also further be applied to instruction manuals or other kinds of algorithmic speech. Thank you. Any questions?
Thank you very much for your presentation. Seems to me that it's quite a complex grammar to work with, and I have one question related to synonyms. So how can you deal with, I don't know, phrase with similar meaning, like, I don't know, eggs, large eggs. I remember something from your presentation. Or let's say spoon, tablespoon, large spoon, small spoon, something like that.
Yes, so the units, for example, for a tablespoon and spoon, we can see that tablespoon is actually, for example, if it has a quantity before it, it's actually a unit. For spoon, spoon is actually considered in this grammar as a keyword for tools. And the synonyms, it doesn't really matter for them. Or for example, if I have a word and in one place has a determiner or adjective or something like that, then it doesn't matter for the structuring because it doesn't go back to see what it used. It doesn't order the steps. It considers them as chronologically. It just labels them and gives a structure based on specifications themselves.
Thank you.
I have a question as well. So as much as I could follow you, there is a similarity between what we are doing and the way the browser works in order to construct the DOM, the document object model. That's from my experience, but the output you used is in JSON format. And I was wondering if you took in the consideration to structure your data using XML. And I was thinking about that because maybe it might be a more powerful instrument from 2 points. Firstly, you can have validation instruments for such a way of structuring data. And then you have the XPath, the way in which you can navigate the information structured in that way. I don't know how familiar are you with XML?
I'm not that familiar. I use JSON because it seemed the most portable and easier to use, and it was also easier to parse for the Angular app. But yes, XML, it could be a good alternative.
Because they are really similar, but maybe from some perspective, XML maybe you can find it more proper. And it would be a more powerful instrument. It's just a suggestion, maybe something you can look into it.
Okay, thank you very much.
Thank you for your presentation.
Thank you.
Good work.
How would you think to adapt the grammar to more languages, to translate to another language?
You have another question, but I think...
Yes, I thought about this. I chose English language because it's more international. I thought about how I could do this for Romanian, but in Romanian we have a more complicated grammar. One way of translating it would be grammatical framework using abstract grammars, but for now, English I think is enough.
Okay. Thanks.
If there are no other questions, we can move on to Popa Maria with using FCA to investigate EC Web of Knowledge COVID-19 related scientific papers.
Hi everyone. Can you see me? Can you hear me?
Yes,
The most used questions.
Okay, you have 12 minutes, Maria. Good luck.
Thanks. Just a second. Okay. Can you see the presentation?
Yes.
Yes, we can.
Okay. So the plan of the talk is I will discuss a bit about some preliminary notions, then define the problem, the apply methods, and in the end, the conclusion and future work. So we'll start by defining what a formal context is. We'll use it through the next slides. So basically, a formal context consists of two sets, G and M, and a relation I between G and M. The elements of G are called objects, and the elements of M are called attributes. And I is called the incidence relation of the context. If you think at real world, so basically almost everything is a formal context if it contains objects and if these objects have attributes. For example, here we have the context of a zoo. Maybe you ask yourself how we can design this context, how we can display them. So through tables where we have the objects as columns and attributes as rows, the other way around, sorry. And for example, in a zoo context, we have animals, and yeah, each animal has some properties which will be the attributes. A lion, for example, a lion has 4 legs. So if you want to display this relationship, we will put a cross in the intersections as here. Then now we have a formal context, but it is interesting to see which are the concepts in this context. But let's see what a formal concept is. So a formal concept consists of a set of objects A and a set of attributes B, having a certain relation. Every object belonging to this concept has all attributes in B, and every attribute belonging to this concept is shared by all objects in A. If we go back and look at the table, we can see that the concepts are full rectangulars with crosses. So if you can build full rectangulars with crosses, we'll get a formal concept. But how we represent this? We represent this with concept lattices, and we'll see what they look like. But let's define the problem. So basically, we all know that COVID-19 implies a lot of changes in our lives as social, economical, and psychological. And people were used to travel abroad a lot, and also researchers to meet at conferences and discuss face-to-face the problems. But with these changes, as you can see with our conferences, we have to move it to online. So it is interesting to see how everything was between this period of time in terms of how many articles were published and which were the research topics that were targeted. And we have a data set with almost 1,000 articles, indexed articles, that were published between 2020 and 2021. They are concentrated on different topics, and we wanted to see which were the countries that contributed to these researches. There were 97 countries and 94 research topics. We were interested to see the author names, the affiliation for each author, the research topic that were targeted, and also the abstracts. So what were the methods we applied? So basically, we first of all, we wanted to see how the articles are spread all around the world. And as you can see in the map, they are split almost everywhere. So almost everywhere there were articles that were published. And then, first of all, we applied formal concept analysis. So for this, we built a context by using as objects the countries and as attributes the research topics. And as you can see, using the FCA tools bundle, we generate a concept lattice. What is interesting in this concept lattice is it's basically like a graph, and each node, this is interesting, is represents a formal concept. So basically, if you look at Poland, Poland is a formal concept. And which are the objects for this formal concept? If you go downwards on all the edges from Poland, we'll find the objects. And if you go upwards on the edges from Poland, we'll find all the attributes related to this formal concept. And if you look at the bottom of the concept lattice, we'll see that Italy were the country which published more and also targeted some research topics that were not targeted by other countries. And then Spain, Germany. Okay, here you can see shortly some research topics related to the countries. And then it was also interesting to see how, which is the relationship between the United States of Canada, which is a well-developed country and with a lot of research, then China, which was the start of the pandemic, and yeah, Canada, which is also well-developed. And as you can see, China was the only one that concentrated on sports sciences, but the United States of America targeted more research topics. Then maybe you ask, okay, but what can you do further with these concept lattices? Okay, so from these concept lattices, you can read you can compute implications and you can read implications. And why are these implications useful? So basically, an implication describes the dependencies between the attributes that are valid in that context. And for our context, we have 191 implications. And why they are interesting? Because if we find them valid in our context, they could be valid also for other scenarios. So in this case, obstetrics and gynecology imply general and internal medicine. If you think, okay, this is not related just to our context, but it is related to other scenarios too, so it can be useful for applying it to recommendations or for filtering. Just imagine someone going in the hospital and have to go to a gynecology department and doesn't know where it is. So people could recommend them to go to internal medicine, and then we'll find a department. Okay, then another method we used were the computing word clouds. What is basically a word cloud? So a word cloud is an image which contains the strings from the data set, and the bigger the size of the string is, the bigger the number of frequency of that string is. So basically, as you can see, if we compute the word cloud on research countries, Italy, as in the concept lattice, is one of the countries that published more. Then we also build one for research topics, and as you can see, the most targeted are medicine, biology, and technology. Okay, another method applied was also computing some clusters on the research topics. We wanted to see if they can be grouped somehow, and for this we took into consideration the semantical, and we use PyC, which is a library for Python, which is trained on a lot of words, English words. And somehow we have three big clusters. One is concentrated more on biology, and the other and medicine, and the other one on technology and some educational stuff, the third one. And then, okay, we have these all index papers, which they were indexed, so they were accepted to good conferences. So it is interesting to see if there is any pattern between the titles and the abstracts, because one key point when an article is reviewed is the title. So we analyzed the titles and the abstracts, and we computed the word cloud for the title words, and we saw that a lot of titles contain in the title COVID, SARS, or COV-DOI. And apart from this, it was interesting to analyze how many words from the titles are included in abstracts. And for this, we did some text processing, because we don't want to take into consideration the prepositions or the articles which are not relevant in our case. So we discovered that there were almost half of the articles that used more than 70% of the words from title in abstracts. So this is something to have in mind when we write an article. So in conclusion, we remark that FCA is an interesting instrument to analyze the data. Even if almost everything moved in online, people still published a lot. There were a lot of articles that were published on different topics. And a pattern to keep in mind when submitting articles is to include in the abstract more words from the title. Future work will include using triadic contexts, trying to generate more implication and to use them, and yeah, generate some predictions. Thank you very much for your attention, and if you have questions.
Yes, thank you very much, Maria. You had, it will be interesting to move to the triadic to see what are the conditions there. Maybe you can have the condition of COVID and non-COVID as two separate things. You had on one slide word cloud with Italy in middle. And you said that on the lattice, you also can see, so that means that Italy is upper or lower in the concept. Can we go to the concept, to the lattice?
Yeah, sure.
And where is Italy?
Here down.
Ah, okay. Okay. And because you said that the objects are countries and
yes.
the attributes are the topics.
Yes.
And the concept, because I cannot see a concept which has two countries. Maybe there are not. Yeah, there are the intersection.
Yes.
Okay. Thank you. I think I have a better understanding now.
What is the reason for which you mixed maybe country names and research domains or concept in the same thing? It's not better to have a separate clusters with region, country, geographical dimension, and another dimension related to research topics or something like that. And in such clusters, it's not interesting to see which are the main things, which are the outliers, which are the spreaders, which are the main nodes in your.
So I don't really understand the question. You mean building the clusters?
You have here European Union country and research area. It's not better to have two separate things.
So basically, I wanted to use this. When you have a dyadic context, you have the countries and the attributes related to them, objects and attributes. So I wanted to see which were the targeted research topics in those specific countries. I wanted to build this relationship between them to see which were the subjects that were targeted in those areas. So
maybe the confusion is that we cannot see the attributes, but I think there were too many attributes to be shown.
Yeah, so basically here I just put some of them, so you can see, but if you put all of the labels on, you won't see too much because the context it's very big.
So I don't know, cardiology and pulmonary disease are two separate areas, and they are somehow related if they have some papers in common or some.
Yes. So basically, as here with where you compute the implication, I just put two of them. So
obstetrics and gynecology.
Yeah, so basically all the articles that wrote about obstetrics and gynecology also wrote about general and internal medicine. So yeah, and there are a lot of implications that have to be interpreted and see if they can be, how they can be used further. I'm not sure if I answer your question.
Okay, thank you.
Okay.
Yeah.
Can answer my question.
Okay, maybe it's hard to grasp if you're not familiar with formal concept analysis, the strength that it gives. Yeah, and maybe if you could have used a graphical representation, you know, of the implication, or maybe you can put the concept, an example of a concept as it is given by the instrument, you know, to better send your message across.
Oh,
so
okay.
You take into account also the strength of the edge. So if there is an edge between A and B, always it's 1 or could have different value. If A and B are strongly connected, then B and C, they have different value on the edge. It's a kind of graph, no, there. All the edges in the graph have the same strength, the same value 1, or they have different value.
Okay, I will think about it. Yeah. So, thank you.
Okay, thank you.
Thank you, Maria.
I think if there are no other questions, I think that we can continue to our next presentation. Andrei Diaconescu.
Yes, just a second. It's okay, light, sound.
Yeah, we can see you. We can hear you.
Just this. Sorry, not this screen.
Okay, we can see the presentation.
Okay. My name is Andrei Diaconescu, and I will present a COMPA. It's an access control matrix processing assistant. Every year, IT systems become larger and more complex, involving more data, more users, and more administrators managing users' access to data. And in this situation, following question arise: in what form data will be organized? Is there well-defined structure under which they organize? What type of access user will have? And for management part, if it's possible to management to know exactly what type of permission user have. A COMPA defined process to create a well-established folder structure with different access and manage users. Also, a COMPA is an application based on API provided by Microsoft for managing objects from Active Directory. Active Directory is a hierarchical structure by which objects can be grouped so they represent a mapping between different resources of the organization. Concept about access control matrix were defined as a security model in 1971 by Lampson.
the model can be as abstracted as a lot of objects O that need to be protected, and a lot of subjects S that need access to these objects. In addition, there are a lot of R writes of form LSO, where S element of S and O element of R, and R is subset of R. A write specify what type of access a subject has to an object. As application for user management in present, mostly use Active Directory Administrative Center and Active Directory User and Computers. These are including on Windows servers, and both applications can be installed on computer from the domain to remote management of server. Another tool is Siena, include both of these. But in addition, allow you to map share folder of the network to make easier to create folder structure when you need. And Group Manager, it's a simple and minimalist application used for permit you to delegate rights to a user or a group to administrate access on some resources. Okay. Acompa was implemented in C# in open manner using a layer-based architecture. As you see in figure, we have GUI for graphical user interface. Operation layer is all operation with file system with Active Directory system, and models are classes used for modeling data and structure of data we use to help us in do task. Okay. Acompa implements third processes, creating the folder structure and security group for this folder for a new project, add or remove users from group based on access metrics, and view users in security group related to a given project. In figure, can you see the steps for process for creating folder structure and security group, starting from data provided by user, project name, project location, and a structure configuration file. As you see in picture for configuration file, root keyword will be replaced with name of the project. After running this process, you will have a structure with name, project, folder 1, 2, 3, 4, 5. This is random name for this presentation. These steps for this process are generate folder names and security group names, create folders. That implies disable inheritance from parents, from root, because this is a big important step when you create a folder structures on shared drive. Create security groups in Active Directory and applying security groups to folders. This is process when you link group with folder between a write. Okay. Second process for add remove user from group based on metrics. If you can see the steps for this process, you will need to provide project name and an access control matrix. This is an example of access control matrix in simple form, where you can see this our folder, users, and which type of writes they need to have, read or read write. This is common because with this type of writes I I work at my job. In first step, you load in application this matrix. You will see if it's load correctly, and after this you can apply this modification on groups. You can save this matrix on group. Okay. And for view user insecurity group relate and given project, this process is for management mostly, because sometimes management needs to know which person have access on the project, and to go back from security groups to access metrics. It's complicated, but you can export in some example of this. These are name of the group, but include folder and type of access and users exporting from Active Directory security groups. Okay. These are results, some screenshots from application for these three processes. Okay. For process one, to check if our application do the right things, you can run this command on project root folder, and will display you the structure. As you see, test project and subfolder folder 1, 2, 3, 4, 5. To check if group were created in Active Directory, you can run this PowerShell command and filter by name to start with your project name. To show if your group are applied with right permission, you can run this command, and you will see for this group you have read access. For this group you have read-write access. When I run the application, I run with administrator account on server directly, and that's why administrators have full access on the disk. But users have access only based on this group. Okay. To show if the second process run correctly and run correctly, and you can see if in mentioned group below are members user you want in matrix. As you see, user 1 from matrix. And for the third process, product you will obtain it on PDF with this same I presented before. Because one of the goals of the application is to help system administrator grant to necessary permission based on the access matrix in the shortest possible time, we measure the time required for the application to load the new matrix by varying number of users. The results obtained can be seen in figure and represent the average of several successive runs. Results in milliseconds. For 5 users in matrix, 10, 15, and 20 users. With random, with 12 security group and random distribution of accesses. In conclusion, Acompa solve problems like most users need advanced knowledge about Active Directory to use Active Directory, Administrative Center, or other application, but Acompa it's easy to use. One of them, and second one is you can create folder structure easier. If you do this manually as system administrator, it will take something like 15 minutes to create the structure representing before, because you must create folder, disable inheritance, after this add security group and so on. Also, when you manage remotely on your computer, you must have installed Active Directory, domain service, and lightweight directory tools to use Active Directory administrative tools and admin and Active Directory used on computers. But Acompa doesn't require this. It runs if your account has member in domain administrator on server. You can run remotely from your machine. Thank you for attention.
Thank you very much also for your attention. Did I understand correctly that your approach works only in Active Directory, or there is possibility to translate your work to other technologies, let's say?
It's only on Active Directory, because it uses Active Directory API in C#. That's why only for Active Directory. I tested on Windows Server 2016 on my only for this. And okay.
Okay, thank you. Other question?
I don't know if I did understand correctly your work. So it is about managing the employees, or
most access on resources. In
both human and non-human.
Human mostly to have access on resources like folders or files, because I work as sysadmin, and some issue are when it's a new project, you must give correct rights. Some access requests for management, some for other part of the development team, and now we do this manually, because Acompa
automatize
yes,
the process.
is for automatize this process.
You automatize the access of users human users to non-human resource like files, projects, folders.
Yes. Yes.
Okay, thank you.
You're welcome. Thank you very much.
I think that we can safely continue to the next presentation.
Yes, Ashil, could you see my presentation?
Yes.
Hi, my name is Nitu Cristian Mihai, and today I'll present you a system who is able not only to understand the natural language, but also to solve logical word puzzles in an automatical way. Natural language understanding is a subtopic of natural language processing, considered a hard AI problem. The text expressed in natural language should be represented in a multiple way, one on which reasoning can occur, so that we can conclude new facts based on what the text gives us as an input. Logical word parsers can be seen as a good application of natural language understanding. In my opinion, a logical word parser is a bunch of sentences interconnected, which are meant to train the logical thinking of someone. The difficulties met by the system when it has to solve a logical word puzzle automatically are represented by the language diversity, the inferences it needs to make in order to find new things, and the background knowledge, which most of the time is not specified in the puzzle. We have in the right side an example of a puzzle with knights and knaves, a very well-known type of puzzles. Knights always tell the truth, knaves always lie, inhabitants can say different things, and the goal is to determine their nature. For every inhabitant, we have to see who is a knight and who is a knave. My proposed solution for solving the puzzle is based on a feature-based context-free grammar for parsing the text. It is represented in a way that the system can understand, such as first-order logic. For this, I use the NLTK library too. WordNet and lemmatization are used in order to find the synonyms of the words from the puzzle to obtain a more diverse lexicon. Named entity recognition is used to find the name of the person in an automatical way, while coreference resolution helps to replace the pronouns with the name of the person, of the corresponding person, so that the system can understand better. Maze4 is used to find the solution of the puzzle. Because I consider that not only solving a puzzle is important, but also the ability to give a user a reply to a question regarding the puzzle, I used Prover9 in order to reply to the parsed questions which can be from the user. The main advantages of my system in comparison with others are the diverse lexicon and the customized grammar I obtain, the background knowledge which can be deduced automatically, and the ability to reply to user questions by giving a proof. Here we can see the overview of my system. The puzzle is given as an input. We have 4 main components: a grammar builder, text-to-file converter, background knowledge, and Maze4 builder. And the output is the puzzle solution. The first step is to build the grammar. Here we have to define the lexical and grammar rules, which are used in order to parse the sentences. In the left side, we can see that we can parse sentences like Clara ate potatoes, which is grammatically incorrect. In order to avoid this type of mistake, we define attributes, which can divide, for example, the nouns into 2 categories based on the number of the noun. The wildcard operator helps in the agreement between nouns and verbs, for example. The system has to understand also what these sentences means, not only to parse them. So we have to define first-order logic semantics for both lexical and grammar rules. For example, having the sentence John sings, we can define the semantic for John and for sing, and the sentence will have a semantic too, which has as a result the 4 representations, sing the John. But we cannot represent in this way even more complex sentences. For this, we use the lambda operator, which is a binding operator applied to a variable, like in the semantic for sing sentences. This operator can be replaced by a first-order logic expression or by a constant, in our case, John, and we can obtain thus the semantic of even more complex sentences. Here we have an example of a grammar for solving a very easy puzzle, a basic grammar which has the concepts defined by us earlier. The next step is to convert from plain text to first-order logic. We have a pre-processing step, a coreference resolution step, which is used to automatically replace a pronoun with the corresponding person name. In my case, it uses a pre-trained module named Neural Coref from Spicy library. We have to parse the sentences using the grammar defined earlier, and we use WordNet to parse the sentences which contains unseen words which were not defined explicitly in the lexicon, but which has a synonym already defined in the lexicon, so that they can be parsed. Here we can see a tree representation for a sentence from our puzzles. You meet two inhabitants, Peggy and Mel. On the first line, we see the semantic of the sentence, inhabitant the Peggy and inhabitant the Mel. This is expressed in first order logic. And on the next lines, we can see how this semantic was obtained. The next step is represented by the background knowledge. We have a type of background knowledge which can be deduced automatically. Named entity recognition is used to deduce the person names. If we don't use named entity recognition, the different person names would be instantiated with the same variable when trying to find a solution, which is not correct. Also, we detect pairs of synonyms from puzzles using the WorldNet. Part of speech tagging is used to avoid a synonymy between a verb and a noun, so basically between two different parts of speech. And lemmatization avoids synonymy between the same words but in different form, like say and tell or says and tell. Typed background knowledge is the one which must be specified by the user. The last step is obtaining the solution. We use domains for model builder. In this example, we have a puzzle and the solution it finds for it. We can see that the person of the puzzles, Homer and Marge, which were detected automatically in the previous step, are instantiated with letters with constants A and B. And the predicate knight is instantiated with both A and B, which means that both Marge and Homer are knights. I said earlier that my system can be seen as a question answering system because it's able to parse the additional questions from the user and to reply to those questions. It uses proof_9 to reply to additional questions and to give a proof. The method is proved by the solution. Here we can see a puzzle with a question and an additional question asked by the user. The sentence to be proved is Marge and Ben are knights. In the bottom, we can see the representation of the proof, how the proof_9 made that proof based on assumptions, on new facts it deduced. And finally, we obtain a null clause, which means that the proof_9 found the proof. So the sentence was proved. Experiments and results. The system was evaluated on a set of 382 puzzles with knights and knaves with variable complexity. Every set of 50 puzzles increased the number of inhabitants from 2 to 8, while the last 32 puzzles were the most complex ones with 9 inhabitants. The grammar file for the puzzles was created on 43 puzzles with different number of inhabitants and was tested on the other 339 puzzles remaining. The performance was checked on 2 other problems encountered, the named entity recognition and coreference resolution techniques. In the table 1, we can see the system performance. Our system parsed correctly a number of 331 puzzles from 339. The other 8 failed mostly because of some undefined grammar rules. Regarding named entity recognition, 342 out of 382 puzzles were successfully found the name of the persons. There are also puzzles where a name like Peggy or Bozo was not recognized, or alter puzzles where it recognized, for example, Ted and Bob as a single person. The coreference resolution had an accuracy of 92.14%. And there are also pronouns which could not be bound to any person names. In other cases, the pronoun was not replaced by the name of the person it should. Both cases led to the incapacity of the system to solve the puzzle further as a consequence. Taking into account that there were 5 puzzles where neither the NER nor the coreference resolution managed to be applied successfully, in total, a number of 73 puzzles out of 382 could not be solved. So we obtained of accuracy of 80% approximately. As future work, I propose to find a way to verbalize the proof given by the proof_9, to improve the named entity recognition and coreference resolution algorithms, and to find new techniques to make the lexicon even more diverse. Thank you for your attention.
Thank you very much for your presentation. Very interesting. In the final slides or in the final of your conclusion, you mentioned that there are some puzzles which cannot be solved. Did you manage to somehow identify or the features which makes these puzzle unsolvable for your approach?
The puzzles unsolved because of the grammar was because I created a grammar based on a number of 43 puzzles and tested on the other. If I had chosen a puzzle which could not be solved and built the grammar on it, it could be solved afterwards.
So if the grammar is in the data set, it could be solved, yes? Always.
Yes.
Okay, thank you. Very, very impressive accuracy of your method.
Thank you.
Other questions, if there are.
I don't have questions, thank you.
Can we go now to the last presentation, maybe?
Yes, so the last presentation, the author is Dan Christian, and the title of the work is Learning Analytics, a New Approach and Tool Support.
Okay, hello. Please bear with me for a moment to share the screen.
Okay.
Let me know if you can see my screen.
We can.
Yes.
Okay, so without further ado, I know that it's pretty late. I will go straight to the presentation. So as you previously mentioned, the title of the paper is Learning Analytics, a New Approach and Tool Support, and it's brought to you by me, Alp Cristian, and my supervisor teacher, Camelia Sherban. So, on today's agenda, firstly, we will present the motivation, then we move and present our goals. We present the adopted approach in modeling the learning and teaching process. We present a possible solution, and in the end, we talk about some conclusions and future objectives. So, motivation. Basically, the teaching learning process needs to adapt to different group needs, and as it is today, it kind of fails in many cases. I'm not saying that it's bad, but it could be improved. And we also need more tools that could be used in an online or blended type of classes, since the pandemic really influenced the way teaching learning is taking place now, be it online or blended, and rarely on class. And now we also need to present information about the academic trajectory of a student in a smart and easy way to understand. In this way, the goals are pretty simple. We want to create a dynamic teaching learning process that changes based on the actual group needs. We want to present the student progress in a smart way and enable self-guidance with the help of learning analytics. And overall, we want to create an authentic learning experience with the help of a specialized tool. And now, how we modeled the teaching learning process. Firstly, we make use of active learning methods. Active learning is basically engaging the student actively in the teaching learning process. And with this comes a greater degree of responsibility for the learner, since the learner has to be engaged in the teaching learning, search for information, filter that information, make the difference whether it's good or bad. However, the teacher is still present and can guide the student when needed. And it helps promoting higher order thinking skills, such as an application of knowledge, analysis, and synthesis. And as you can see here on the picture on the right, this is the learning cone proposed initially by Edgar Dale. And we can see that on the base of the pyramid, we have active learning, and on the top, we have passive learning. Well, those percentages represent the retention rate after 2 weeks. We can see that passive learning methods are not so good for the long-term knowledge. But if we teach others, we practice by doing, then we have a higher chance of easily assimilating information. Now, we want to model an agile teaching learning process, and agile methodologies are known from software engineering, and we adapt them in education by the cyclic repetition of some steps, be it for the teaching cycle or the learning cycle. They both start from a common midpoint, namely lecture tutorial step. And as for the teaching cycle, after the lecture or tutorial, the teacher has to monitor the class activity. And after that, it needs to adjust such that it complies more with the actual group needs. And as for the students, they firstly are in the role of observant, assimilating new information presented by the teacher. After that, they move to practice step when they have to practice, namely to sediment the newly presented information in practice problems. And after that, after building a foundation, they do an independent step study. Namely, they will start studying alone, and in the end, to see whether they did well in the independent study step, they share the knowledge with the class. And now, as is of main interest for us, learning analytics. Well, learning analytics, basically you gather student activity data and process them such that they can enable easy track of student progress. And this is basically a smart way of detecting the adopted learning patterns. So basically, if we have a student that is actively engaged and constantly, you will see a nice pattern. But for students that like learn 2 nights before the exam, you will see that, well, he did nothing the entire semester, but then you see the Mount Everest in activity before the exam. However, as I've mentioned, it's easy to see the patterns. It's easy to see what students need additional support, and can be seen as a way of modeling an agile teaching learning process. Previously, I've mentioned that we want to create an authentic learning experience. So for this reason, we've used gamification of learning. And as a definition, a formal one, gamification is the use of game-inspired techniques and mechanisms in order to engage people, motivate action, promote learning, and solve problems. We create an authentic user experience, since basically gaming has serious success no matter the age ranges. And the main goal for our part was to enable the idea of a virtual community and promote sharing of information. So basically, we want to enable the collaboration between student and student. Moving further, we will present the solution that we've implemented, namely Closer e-learning platform. So Closer is a cloud-based e-learning platform based on active learning methods and teacher-student collaboration. It features a question proposal system that is used for the collaboration between the teacher and student. Mainly, it's used for preparing for exams by taking quizzes, since students can generate quizzes based on their needs. It features elements of gamification like user levels, badges, and ranks. And ranks are used namely for enabling the idea of a community. And the most important aspect for us, we have student-based metrics that are used for presenting the student evolution. On the left, since I've mentioned that we have a cloud-based platform, we can have an overview of the architecture, but I don't feel that this is of interest right now. And now moving further, it's playtime. So we go to the platform. Manolescu_UBB is a teacher account, since on the platform we can have teachers and students. This is the main panel. Here we have some of the courses, and since my supervisor teacher teaches the advanced programming methods, I will go to this course. Here's the main page of the course. We have more possibilities. Here we have a general description. Here we have the syllabus items, and what is of interest, each item from the syllabus has some key terms, some tags that are actually inspired from the hashtag phenomenon from the social media, and it's aimed to bring to a wider audience some questions. So basically, we want to go to the smart grading management section. Here, here we have elements of gamification, badges, awards, study levels management, and what is of interest for us, student progress and statistics. Here we have the students that are already enrolled. We will go, for the sake of the example, to Mihai Marcu, which isn't an actual person. So here we have the statistics, the student-based metrics that we are interested in. And we have the current level, we have the rank, which will tell the student, well, you can have multiple friends that are Palladium Angels. You have also a badge. here's your war, you're kind of at half your journey, and here's your progress in terms of levels when you achieve them. So basically he started from the first level in the 2nd of February, then at some point he moved to the 2nd level, and now he has achieved 4,600 and some points. Moving further, we have the contributions that the student has given. We have them in time to see the pattern of activity and an overall situation, and also he or she can compare with the course situations. Namely, each course has more modules, just like in real life when we have course 1 in week 1 and so on. So we have modules, and the questions are structured in a color codified manner. Namely, we have accepted, under review, and sent for revision. For module 4, we have 55 questions that are all accepted, but for instance, for module 7, we have a question that's under review. Moving further, we have the test progress, which is pretty straightforward, is the progress that the student has made. And now, more importantly, how many questions the student has covered from the data collection, the student activity on the platform, and last but not least, as I've mentioned, we have some tags, and here we have the tags that the student has covered and their in percentages. Okay, and one last slide and we are done. Conclusions and future objectives. Well, as part of this journey, we learned that the educational system is basically like a puzzle. However, unlike regular puzzles, this puzzle can admit multiple solutions. And in this way, we only proposed a possible solution to the puzzle based on active learning methods and an agile model teaching learning process. And as for the future, there are many things that we can do, but regarding to learning analytics, maybe using AI specialized algorithms that will predict the student progress in future will be one thing that should be taken into consideration. And thank you for all the attention. Sorry if I took too long. This was it. Please let me know if you have any questions.
You did just right, under a minute of your time.
Okay.
So, if there are questions.
So, should I understand that this is just, in a way, just the beginning of a larger image? So you managed to implement in cloud, if I'm correctly, a kind of e-learning systems, and you managed to implement some things related to these concepts, yes?
Well, yes, it's cloud-based. The architecture is automated using Terraform. And as for the features of the platform, basically we have some main features. One is the question proposal system, where the student proposes questions and the teachers will review them. If the questions need updates, then a chat between the students and teachers from that course will be enabled so that they can collaborate and bring the question to its best. To its best. After that, the questions that are accepted will be gathered to the data pool collection. And from this data pool, students can further generate quizzes. Each question is characterized by some tags that describe the main topics covered by that question. And in this way, the student can generate tests based on his needs or her needs. And we also feature gamification, like we replace the grading system with points and levels. We encourage student collaboration with the ranks, and we have badges in order to give the student the feeling that he is not unnoticed, and the teacher actually knows that he tries to make progress and he may be struggling, but the teacher is there for the student. And I've used active learning since I feel that it's the best fit for an e-learning system. But yes, it's the beginning since a project is actually done when you consider it done. And there are so many things that can be further improved or added to the platform. For instance, some synchronous type of learning via video streaming, or I don't know. As for the moment, we have notifications via WhatsApp and email, but I don't feel like this enabling some synchronous type of learning. So I hope I've answered your question somehow.
The student e-learning experience, it's personal. So one student will ask 3 questions, will be asked 3 questions. Other students will be asked 4 or 5 questions. Maybe they behave differently in the first or second question.
Asked in what manner?
So do you adapt the learning methods to the student, let's say, to the student performance?
So student performance is kind of modeled with the help of quizzes, and for the quizzes, he or she may choose what topics. So in this way, it's kind of helping them to more like prepare for exams, not necessarily to present their actual status, academic status, but this can be modeled in such a way that the teacher will ask students to generate some kind of test, and somehow in the future it can be used as a tool for exams. Yes, in this way.
Okay, thank you.
Okay, thank you very much.
Just a moment, I have a couple of questions as well.
Okay.
Get off so easily. So you had the slide there where you said the last point, so teach others, meaning that you have 90% teaching. It means the teachers learn more, isn't it? So we are learning the most because we are teaching others, isn't it?
Yes. Yes. That's
your idea, as far as I understood it, is to involve students more to collaborate,
yes.
and I think from what I understood is that by proposing quizzes or questions and the solutions as well, I assume, they collaborate in making quizzes for training for themselves and for the others, and that's the collaboration, or that's the part of teaching others.
Yes, that's the main idea. I couldn't have summarized better.
Okay, and you had on another slide graph, a very positively designed graph with accepted, submitted questions and under review. But isn't there a possibility that you would have rejected questions?
Okay, so I guess you can see here the graph. Well, the main idea is to make the best out of each try a student has. Basically, if we reject, that student might feel somehow, well, I tried hard, but look, it didn't end well. I know that if you go with a positive thinking, you learn the best out of the worst. But in this way, we want to help the student to achieve in the end something positive without giving him a negative experience. So in this way, instead of rejecting a question, we put it under revision. So the student is enabled a chat with the teacher, and they can talk, okay, and the teacher can say, okay, look, the question is kind of good, but maybe the level of difficulty is easy, and you may formulate the question in another way. Or maybe this answer is not really suitable, or something like that. So we want to bring an positive view and help them achieve something positive without feeling, I don't know, bad in a way.
Yeah,
Without
but maybe they totally misunderstood the subject, and that's why the question is not okay. And I don't think that kind of artificial format it's healthy, because the students and all of us should accept the failure as well as the good parts.
Well, it can stay under review.
Yeah, thank you. And another point is that we actually, during this epidemic, we being forced to go online. I discussed with a bunch of my colleagues, and I came to the conclusion that we, even though it's not it cannot be seen, we are doing what you're proposing, because in the classroom, when we are teaching, just by looking at the audience, if the concept was understood or not. So we are already doing it, and that's why I think that replacing us is not yet possible. We still have a value in the classroom.
Well, yes, teachers always had and will have a value in the teaching, learning processes. It wouldn't
even though at the superficial level you might think that it's not so. We have some qualities that they are hard, or you are trying to replace, and it's very good through artificial intelligence and everything else, but they are there.
Yes.
Thank you for your work, and keep up the work. We are in need of such instruments, and yeah, more so that they're from the point of view of students.
Okay, so thank you for your time.
Thank you very much.
Screen.
So we are 3 minutes to our finishing line. So we did really good.
Yes, very good presentation. A lot of students, a lot of work.
Yeah. Yeah, and a lot of enthusiasm, which is a very positive thing.
Yes.
They have this drive to do research and write code. It was a really nice collaboration. Thank you.
Thank you very much, Rose. And we have to thank the works of all the students, both from Technical University and Babeș-Bolyai University. They do very nice work, nice job. Thank you.
And congrats to all of you, regardless of the final results. The work is appreciated. Thank you. I think we can close now.
I think that we can leave this panel, and then we will come back to in general for the award section. Yes.
Yes.
Thank you.
Thank you. Have a nice day. Nice to meet you.
Bye.
Bye.